Hey, what's going on everybody? It's your bro, hope you're doing well, and in today's video I'm going to show you everything you need to know to get started working with React.js. So why don't you go ahead and sit back, relax, and enjoy the show. React is a JavaScript library, not framework, that's used to easily build and arrange user interfaces for web applications. React focuses on building a web application using these things called components. A component is a self-contained section of code that functions as a reusable building block. Think of Legos. You could say a Lego is similar to a React component. Each Lego represents a section of reusable JavaScript and HTML code. We can build a diorama or other complicated structure from these Legos if we use enough of them and in the correct places. React uses a syntax extension of JavaScript known as JSX, meaning JavaScript XML. JSX allows you to write HTML-like code within your JavaScript files. React also utilizes a virtual DOM. It's a lightweight version of the real DOM of a web page. We can keep track of any changes made to the virtual DOM and only apply that specific change to the real DOM without needing to refresh the entire web page. Only that specific section. This reduces rendering performance overhead. Before we do begin, you will need to know JavaScript since React is a JavaScript library. Everything up to arrays, classes, objects, and ES6 features such as arrow functions will be necessary. HTML will also be mandatory since our React components involve rendering HTML elements and applying CSS. I do have full free courses on my YouTube channel on these topics if you need to catch up or you need a refresher. So that's a quick overview of React. We'll move on to the installation instructions next. We're going to download Node.js from this URL, nodejs.org. Node.js is a back-end JavaScript runtime environment. It executes JavaScript code outside of a web browser. We're mostly interested in the Node package manager that comes with it. Let's download the latest version of Node.js. Open it when the download is complete. Select Next. Read the license agreement. Yes, I did read it that fast. Next. Select a destination folder. I'll keep it as is. You can define a custom setup, but that's outside of the scope of this tutorial series. We'll press Next. We'll skip Tools for Native Modules. Press Next. And install. Then finish. You'll also need a text editor. I recommend VS Code. Since you've made it this far in my web development series, I'm assuming you already have one downloaded, which you can get from this site, code.visualstudio.com, and select the correct download for your operating system. Within VS Code, I'm going to create a project folder. Let's go to Explorer, Open Folder. Just for convenience, I'll place my project folder on my desktop. I'll create a new folder. I'll name mine Website. Then we will select this folder. We're going to need to open up Command Prompt if you're using Windows, or Terminal if you're on Mac. You can also do this within VS Code. Go to the hamburger menu up top, Terminal, New Terminal. We're within our website folder. We will type the command npm, meaning Node Package Manager, create Vite at latest, meaning latest version. Vite's a development server. It's a modern replacement to Create React App, which is now outdated. Hit enter. We'll need a name for this project. A common naming convention for a user's first React project is My React App. That's a common name that you'll see. Enter. Select a framework. Using the arrow keys, we can select whatever framework we would like to use. We will select React. Hit enter. Are we going to use TypeScript or JavaScript? We'll stick with plain JavaScript. Alright, here are the last few commands, and they are given to us. We'll change the directory to our React app, cd, meaning change directory, my React app. And that's the name of the folder where our project is located. npm install, that is the second command. The last command is npm run dev to start the development server. npm run dev. Alright, so our web server is found at this address. Let's copy it, then open up a web browser. Let's paste that address. And here we are within our development server. This is a sample project that's given to us. It even includes this little counter. Hey, this is Future Bro. I was editing this video and I totally forgot to mention how you can restart the server if you close out of it. All you gotta do is open up a terminal. Let's go to terminal, new terminal. We have to be sure that we're within our application folder. I'm going to change my directory by typing cd, the name of the folder, my React app, then npm run dev to start the development server. And let's refresh that. Yep, it seems like it's working. So yes, I forgot to mention that. That is all. I'm quickly going to cover the project structure of our React application. We'll begin with the Node Modules folder. This folder contains external libraries and packages that our project relies on. A few of which are build tools, utility libraries, routing libraries, just to name a few. We won't be spending any time directly in this folder, but you should still be aware what it's for. It just contains external libraries and packages that our project relies on. Next, we have the public folder. The public folder contains any public assets, one of which in here is a Vite image. It should be this image right here. This folder can contain public fonts, images, videos. They're not bundled during the final output. They're typically available via a URL. Just to demonstrate, I'm going to delete this image file and see what happens. Yep, and that logo is gone. So my Vite logo was a public asset via a URL. And let's put that back. Then we have the source folder. We'll spend 99% of our time within the source folder. We have an assets folder that can contain images and videos. The assets folder is very similar to the public folder, but files within the assets folder are bundled during the final output. Public assets are not, and they're generally available via a URL. My React image is within the assets folder currently. We have a main.jsx file. Remember that JSX is JavaScript XML. In a way, this functions as our main JavaScript file. React works with components. We're adding a single component, an app component, which we are importing. So let's take a look at our app component. The app component in this example, you could say, is the root component. We have two different style sheets, a style sheet for app, and we have an index.css style sheet. This is the main CSS file for our application. We're importing this file from our main.jsx file, right here. So that's the source folder. Then we have an index.html file. This is the main entry point into our program. Within the body of our document, we have a div element with an ID of root, as well as a script to our main.jsx file. A few other things you should know about is this package.json file. JSON files are structured in key value pairs. This file contains metadata about our project, such as the project name, the version number, what build we're using Vite, and the React version number, just to name a few. Alright everybody, so in just a moment we will be creating our first React component. We already do have one component, that is app. Right now this is serving as a sample project for us. Then we are importing app to main.jsx. This is our main.jsx file. Think of it as the main JavaScript file. We are creating a root element and including our app component. Within our app component, we do have a function. Delete everything within this function. That should eliminate our sample project. And we no longer need these imports. We can delete them too. But you do want to keep this export statement. Components can have dedicated style sheets, which you can see here for app CSS. We are going to delete this because we no longer need it. We do have an app component that's going to serve as the root. We will add other components to our app component. Our app component ties them all together. To create a new component, go to your source folder. We're going to right-click, then go to New File. We will create a component for a header. The extension is JSX because it's a JavaScript XML file. We will be working with function-based components. We will create a function with the name of header. Do pay attention to the capitalization. Then we would like to export this component so we can import it elsewhere. At the end of this file, type export default, the name of the component, header. Within our header function, we can write a combination of JavaScript and HTML. All we're going to do within this function is return something. Return, parentheses, semicolon. Within the return statement, you can write pure HTML. I will create a header element. So React components, they're only capable of returning a single element, but you can place children elements within. Within our header element, I will create an h1 element with text of my website. Just to be sure everything is working, let's save. I'm holding Control S on Windows. We will go to our app component, then import the header component. So within app, we will type the statement, import the name of the component, header, from a location. That location is going to be ./header.jsx. We can now use this header component. Within our app component, we will also be returning something. So we will need a return statement. Return parentheses semicolon. What are we going to return? I would like to use my header component. So to add a component, we need a set of angle brackets, then type the name of the component, header. Like this. They're a pair of two, and the second one is closed. That's why we have a / preceding it. We now have a header component. You can shorten the syntax as well. Take your component, end it with a /. That also works too. It's a shorthand way of writing the same thing. Let's head back to our header component. We'll add a few more elements. After our h1 element, let's create a navigation element. Then within the navigation element, we'll create an unordered list. Within the unordered list, we'll create a few list items. The first will be home. These are list items you would typically see for a navigation bar. Home, about, services, and contact. We now have our unordered list. I'll enclose our list items within anchor tags to make them hyperlinks. href equals, I don't want these to go anywhere, I'm just going to leave these empty. I'll add a $. And then be sure to close these anchor tags. We'll place our text within the anchor tags so they are now hyperlinks. Okay, let's do that for the other list items. There we are. Then after my navigation element, I will add a horizontal rule to make it look nice. Okay, there is our header component. We no longer need to work with this header component. We do have some styling already applied. Those styles can be found within index.css. If you would like to start fresh and eliminate all of these styles, you can delete everything from here. Then you do have HTML with no CSS. In a future video, I'll show you various ways in which we can apply CSS to a React component, but for now, we'll just keep this the same. Our header element is now complete. We will create a new element for a footer. Again, go to our source folder, right-click, go to New File, footer.jsx. We are creating a function-based component. It's a function that's going to return a footer component. Then, at the end of our script, we will export default, the name of the component, footer, so that we can import it elsewhere. Our footer is going to return something, so we need a return statement. Then, within the set of parentheses, we can return a single element. We will return a footer element. But remember, you can place children elements within an element. It still only counts as one then. So what do we want to do for our footer? I'll include a paragraph element. Within the paragraph element, I'm going to add a copyright symbol. To add a copyright mark, type ampersand, copy, semicolon. Then afterwards, I'll add your website name. All right, now we need to import this footer. Going back to our app component, we will import footer from footer.jsx. Then I would like to include a footer component after the header. Now pay attention to this. We're returning two components. We have this warning. We only have the capability of returning a single component. That's how our return statements are designed. JSX elements must be wrapped in an enclosing tag. Do you want a JSX fragment? So, since we only have the capability of returning a single enclosing tag, we're going to enclose our components with what's known as a fragment. It's just an empty set of angle brackets. So we will enclose all components within a fragment. And that should work. We have our footer component following our header component. We have our header and our footer. Let's make a few more changes to our footer. I'm going to zoom out a little bit. Within our return statement, we can insert some JavaScript. To insert some JavaScript, you need a set of curly braces. I will create a new date object. This is some JavaScript code. New date, parentheses. I would just like the year. I will follow this object with get full year method. Let's save and take a look. So I'm filming this video near the end of 2023. Your web application should return the current year whenever you're watching this. All right, our footer component is now done. I'm going to create a component for an unordered list to sandwich between our header and our footer. I'll create a component for food. We will go to our source folder, create a new file. This component will be food.jsx. Again, we are creating a function-based component with the name of food. Then we will export this component when we're done. Export default food. Be sure to add a return statement. Before we add anything to the return statement, I will create some JavaScript variables. So normally, if you're adding JavaScript code within the return statement, you need a set of curly braces. But outside of the return statement, you don't. I will create two JavaScript constants. Const food1. Pick some food. For me, I will pick an orange. Let's make that capital. All right, then let's create a second food variable. Food2, for me, will be a banana. Within the return statement, we can utilize these constants. What do we want to return exactly? I will return an unordered list. We'll have a few list items. 3 to be exact. My first list item, I'll just add some text. I'll add an apple. Just to be sure that everything is working, let's import this food component from our app component. Again, we need an import statement. Import food from food.jsx. We can now use the food component. We will add that after the header. We will add food. There is our first list item, an apple. Okay, let's head back to our food component. For our second list item, I will add food1. That's our constant. Now pay attention to this. If I type food1, well, we're literally printing the text food1. Since we're within our return statement, I would like to include some JavaScript code. We're including a JavaScript variable. So I need to enclose this variable within a set of curly braces because we're within the return statement. And now my second list item is an orange. Then let's include food2. But I'm going to add one more thing. Food2. However, I'm going to use the built-in to uppercase method just to demonstrate that we can use JavaScript functions. All right, and there is our unordered list. We have an apple, orange, and a banana. So these components are now complete. And the cool thing about React as well is that we can keep on reusing these components if we would like. I would like a couple food components, so I will just paste another component. We now have 2 food components, or even 3, or 4. You can rearrange these components however you would like. By rearranging them, we can change the feel and style of our web application. For demonstration purposes, I will put our footer on the top. That doesn't make any sense, but I just want to demonstrate. So our footer is now on the top, followed by the header, then the food component. Or maybe I would like the food component on top. We now have our food component, footer component, then our header component. Alright everybody, that is an introduction to React. React is all about reusing components. A component is a small section of code that can include JavaScript and HTML. Your function will return that code and make it reusable. And that is your introduction to React. Hey, what's going on everybody? In today's video, I'm going to get a little more in depth with creating components. And by the end of this topic, we will be creating our own card component. So sit back, relax, and enjoy the show. In today's topic, I'm going to get a little more in depth with React components. As we've discussed in the previous topic, a component is a section of reusable JSX code. It's HTML-like code that can contain JavaScript. I thought today we could create some card components. Card components are fairly popular with React applications. Typically, they involve a picture, a title, and a description. You can use cards for all sorts of things. In the previous topic, we did delete all of the contents within our app function. Let's go ahead and do that now if we haven't already. And we'll delete these imports. We will not need them for this lesson. In the previous topic, we did have a style sheet for our app component. We can delete this too. We are now ready to begin. Within our source folder, we will create a new file. The name of the component will be card. This is a JSX file. JSX meaning JavaScript XML. Our components will be function-based. Function, type the name of the component, card, parentheses, then curly braces. We will be exporting this component so that we can import it elsewhere. So type export, default, the name of the component, card. Within our card function, we will be returning some HTML-like code. We'll begin with the div element. We will be applying some CSS styles. We will need to set the class. However, with JSX, class is a reserved keyword. To set an element's class, we have to instead use class name. Do pay attention to the capitalization. The N is uppercase. Okay, we will set this div section equal to card. So cards typically have an image. We'll include an image element. We'll set the source later. They usually have a title. We'll use an h2 element. And a description. We'll include a paragraph. For our h2 title, why don't you go ahead and type in your name? I'll type in my YouTube channel name, but feel free to use your own name. Then let's add a description. For the description of your card, type in what you do for a living, or if you're a student, what are you studying? For me personally, I make YouTube videos. And add a hobby of yours. I make YouTube videos and play video games. So far, so good. Let's import our card component just to be sure that it's working. Within our app component, I will at the top import the name of the component, card, from a file location. These files are right next to each other. So I will type ./card.jsx. Within our app component, we will return, within the return statement, list the component we would like to return. We will return our card component. To include a component, within angle brackets, type the name of the component. These are typically in pairs. You need an opening tag and a closing tag. And there's our card so far. We'll be applying some CSS styling momentarily. There is a shortcut in place of using an opening and closing tag. Take the opening tag, end it with a /. That's also valid. Let's head back to our card component. We'll include an image. Within our opening image tag, it is good practice to set the alt attribute, just in case this image can't be displayed, or if somebody is using a screen reader, the alternate text will be displayed, or read out loud. We'll include a profile picture for us. Let's set the alternative text to be profile picture. We're going to set the source attribute. Now, I recommend pausing the video and finding a profile picture of yourself from, Facebook or Twitter or whatever you use for social media. Pick a smaller picture. Something around 200 by 200 pixels would be decent. If you don't want to follow along, You can include a placeholder image just for this lesson, which you can get from this site. This will be an external URL, https://via.placeholder.com/150. That will give you a placeholder image. Otherwise, if you have an image you would like to use, I'm using the profile picture from my YouTube channel. All we gotta do is place this image within our assets folder. From our card class, we will import that image. Import. Then we need a name for this import. I'll name my import profile pic from a location. So we need to navigate to the assets directory, then get our image. // the assets directory / the name of the image. So mine is profile and it's a JPEG. Yours is likely going to be different. Do pay attention to that. Profile.jpg. For the source attribute, I will set this equal to a set of curly braces. Then we will include our profile pic that we're importing. There's my profile picture. Depending on the dimensions of your profile picture, it might be fairly big. You may want to choose a smaller image, or otherwise within our CSS file, we can change the dimensions of the picture. Okay, let's head to our CSS style sheet. We already do have some global CSS properties already applied, but I'd like to start fresh. Let's delete everything within the CSS style sheet. That should eliminate all CSS within our web page. We will select the name of the class, card. Remember that with JSX, we use class name, not class. Within our index CSS style sheet, let's select our card class. I'm going to go through these CSS properties real quick. We should already have some experience with CSS. Okay, let's add a border. Border, 1 pixel solid. I'll set this to be black. I do like using HSL values. I'll pick a light gray color. Let's set the lightness to about 80 for the border. I'll set the border radius to be 10 pixels to round the corners. The corners should now be rounded, as you can see here. I'll add a box shadow. The first value is for the horizontal offset. The second is for the vertical offset. The third value is for the blur radius. I'm going to pick a lighter color though. So I'm going to select black, change this to an HSL value. But I'm going to change the transparency to be 10%. So 0.1. That is not bad looking. Okay, let's add a little bit of padding. 20 pixels. Padding is found between the elements and the border. So if I were to increase this, we have more padding, but let's stick with 20. I'll add some margin. Margin is for the space outside of the border. Let's go with 10 pixels. I'll text align center to center the elements within. Text align center. I'll set a max width for the card to be 250 pixels. Then I will set the display to be an inline block. In case we have more cards, they'll at least flow within our container if we have more. Because normally divs are block level elements. Okay, so let's work on the card image next. We'll head back to our card component class. We'll add a class name to the image element. Class name equals, let's say, card image. Go back to our CSS style sheet. We are accessing our card class, then access the card image class within. I will set a max width. I will set a max width to be 60% of the width available. I will set the height to be auto, to automatically resize. If you would like a circular image, you can set the border radius to be 50%. I'll add a little bit of margin on the bottom, with margin bottom 10 pixels. All right, let's work on our title next. Going back to our card component, Let's add a class name. The class name will be card-title. Going back to our CSS style sheet, we will select our card class, then select the card title class. With my card title, I will set a font family to be pick a font. I like Arial. I'll set a backup of sans serif in case Arial can't be displayed for some reason. I'll set margin to be 0 to remove any margin. I'll set the text color too. We'll set the color property to be pick a color. Again, I'm using HSL values. I'll set the lightness to be 20%. Now let's change our card text. Going back to our card component, within our paragraph element, we will set the class name to equal card-text. Going to our CSS style sheet, we will access the card class, then access the card-text class. I'll set the font family to be Arial as well. And I will change the color. I'll set the lightness to be 40%. Again, I'm using HSL values. Maybe 30. I would say that looks decent enough. We have now created and styled a card component. Within our app component, we can reuse the card component. However, if I were to add another, well, JSX elements must be wrapped in an enclosing tag. Our return statements are only designed to return a single element. You can enclose all elements within what is known as a fragment. It's an empty set of angle brackets. Then technically, we're only returning a single element. We now have 2 cards. However, they are identical though. And we can use this card component whenever we want. I can include 4 if I would like. Alright everybody, so that is us making a card component. In the next video, I'll discuss props, where each component can have different values, because we don't want all of our components to look the same. And that was some React practice by making a card component. Yo, what's going on everybody? So in today's video, I'm going to show you a few ways in which we can style React components with CSS. This topic doesn't include external frameworks such as Tailwind or preprocessors such as Sass. I'm going to cover a few of the more basic techniques, including external, modules, and inline CSS styling. We will need a component to work with. Let's begin with the button component. Let's go to our source folder, new file, button.jsx. We'll create a function-based component because we like function-based components. Be sure to export it because I sometimes forget to do that, so let's do it now. Export default, the name of the component. Then we will return a single button element with text that says, click me. Normally when setting a CSS class, you use the keyword class. However, in JSX, that's a reserved keyword. We'll instead use class name with a capital N. I'll set my class name to be button. Alright, then we just need to import this button component. Going back to our app component, that's the parent, we will import button from its location, /button.jsx. And now we have a button component to work with. There's my button. Let's begin with external CSS styling. We should already be a little familiar with it already. Heading to our index CSS style sheet, we can apply some global styles. We will select the class name of button, dot to select a class, button. Let's apply the following CSS properties, but feel free to make any changes or alterations. I will begin with a background color. I've already pre-picked a color. Personally, I like using HSL values. 200 for the hue, 100% for the saturation, 50% for the lightness. That will give you a light blue color. For the font color, that would be the color property. I will set that to be white. For padding, let's say 10 pixels by 20 pixels. Border radius to round the corners, I will set that to be 5 pixels. Border none to remove the border. Then let's change our cursor to be a pointer when we hover over the button. That's not a bad looking button. I am zoomed in to like 300%, just for this demonstration. Alright, we have utilized an external CSS style sheet. They're easy to use for simple projects, such as making a YouTube video tutorial. It gives you flexibility with media queries and pseudo-selectors. You can use external style sheets to apply global styles throughout your web application. However, using external style sheets can lead to naming conflicts, especially when you have more components and classes to work with. If you have a large web application, you'll likely have all sorts of different buttons. You would need a strong naming convention and good organization. 2 buttons you may create might have the same class name by mistake. And with large applications, it might be difficult to keep track of all the different class names. Moving on to method 2, let's cut all of these properties, save. We're going to create a module now. That's the second method. We'll create a dedicated CSS style sheet specifically for each component. What you may see some developers do is they'll create a new folder specifically for their component. Let's create a new folder, which we will name button, the name of our component. Let's move our button component to the button folder. Let's move it. Be sure to update any imports as well. My app component is now importing the button component from the button directory. Within our button folder, we'll create a new file. This will be a CSS style sheet, which we will name the name of the component, in this case button.module.css. Let's paste all of those properties that we cut before. Now from our button component, we will need to import this module. At the top, we will import styles from the location of that module, /button.module.css. For our class name, we will use a set of curly braces to use a dynamic value. Our class name will equal our import of styles dot the name of the class, button. And there's our button again. The nice thing about modules is that it avoids naming conflicts because a unique class is going to be generated for you via a hashing algorithm. If I were to right-click on this button and go to inspect, this class name is unique. It's generated via a hash. So with modules, we don't have to worry about naming conflicts. Modules are also convenient if each component has its own unique style. However, a few of the downsides though with using modules is that it does require additional setup, and global styles aren't applied easily. You would have to import them from elsewhere, and that's a whole thing. Let's remove our button component from the button directory. Let's put it back in source. And delete our button directory. Going to our button component, then remove the import as well. We don't need that anymore. Now we're going to use inline styles. What you see some people do is they'll create a JavaScript object named styles. Styles equals a set of curly braces for an object. Let's paste all of those CSS properties. We're within JSX code right now. We can't use any dashes. We'll switch to a camel case naming convention. All values should be strings. Each property should be comma separated. Let's remove our class name. We will set the style attribute to equal use a set of curly braces to insert a dynamic value. We will insert our styles object that contains all of these CSS properties. And now we have done inline CSS styling. Inline CSS styling is convenient and easy to understand. It prevents global style conflicts because we're not working with class names. It's great for isolated components with minimal styling, such as a like button or a subscribe button. However, inline styling can be increasingly less maintainable in large applications. It reduces the readability of your components, especially if you have a lot of CSS properties. It's not great for any complex styling, such as responsive CSS. It tends to be better for components with minimal styling. Alright everybody, so those are 3 different ways in which we can style React components with CSS. External, which is great for global styles or small projects. Modules, which is preferred for individual components that have their own unique styles. And inline, which tends to be good for any small components with minimal styling. Use what's best for your project, or your own personal preference, or whatever your team prefers if you're working on a project together. There's no one-size-fits-all approach, unfortunately. Myself, I prefer to use modules, but throughout this series I'm going to be using a lot of external CSS, just because our projects are really small. And well everybody, those are a few ways in which you can style React components with CSS. Hello everybody, so today I gotta explain props. Props, short for properties, they're read-only properties that are shared between components. A parent component can send data to a child component. When you include a component within a parent, you can send that child component key-value pairs. In the last video, we made cards, but all of our cards were identical. Using props, we can send a child component individual values so that they're all unique. Let's go over an example. We're within our app component. I will create a new component. Let's go to our source folder, go to new file. We will create a component for students to display student data. Student.jsx. We need to create a function student, parentheses, curly braces, then don't forget to export default the name of the component, student. In order for this component to accept props, this function needs a props parameter. Props is going to be a JavaScript object. So let's add our return statement. We'll include a few HTML elements. We'll start with a div. Within our div, I will include a paragraph element. Within our paragraph, we'll add the text name, colon, space. We'll include a set of curly braces to inject some JavaScript. Let's take our props, this is an object, access the name property. However, we still need to pass in a value for the key name. So heading back to our app component, we need to import the student component. Let's do so at the top. Import student from the location where the student file is found. /student.jsx. Let's include a student component within our app component. Student. Now, if I would like to send some data to my student component, student is going to be the child in this case, app is the parent, we'll need to list key value pairs. The key will be name equals some value. For the value associated with the name key, let's say SpongeBob. When I save and update everything, we have the name SpongeBob. When we send key value pairs to a component, they're all stored within this props object. To get the value associated with the key, you type props dot the name of the key. That will give you the associated value. On my webpage, I'm going to zoom in a little bit just so you can see it. That's good for now. Heading back to our app component, let's send another key value pair. Let's send an age. If you're going to store some data as a value, if it's not a string literal, you got to enclose it within curly braces. Let's say SpongeBob, his age is 30. We now have access to this age key. Heading back to our student component, let's create a new paragraph. Age, colon, space. To include some JavaScript, we got to use a set of curly braces. We are accessing the props object, dot, access the key of age. SpongeBob's age is 30. Okay, let's send is student. Is SpongeBob a student? We'll create a key of is student equals, add a set of curly braces. Is student will be a Boolean, true or false. SpongeBob is in boating school currently, he is a student. Let's save. Heading back to our student component, I'll include a new paragraph. Student, colon, space, curly braces, props dot is student. SpongeBob is a student, that is true. However, our Boolean is not displaying. So with a Boolean, I recommend using the ternary operator. If is student within props is true, then we'll return a string literal of yes. Otherwise, will return a string literal of no. Let's update everything. Yes, SpongeBob is a student. You can place complex JavaScript code within your HTML code. Booleans don't display directly to the DOM. You typically find them used within ternary operators or some sort of conditional. If some value is true, return or do this. If not, do something else. Now, if I were to pass in a Boolean value of false, well, that will change to no. SpongeBob is not a student. Let's change that back to true. Now, before I include a few more components, I'm going to do a little bit of CSS styling, just so that all of this is going to be more readable. I'm going to zoom out to 100%, where it was originally. Within my student component, within the enclosing div element, I will set a class name. Remember that with JSX, you have to use class name, not class, because class is a reserved keyword. Let's name this class student. Then heading to our CSS style sheet, index.css, feel free to clear out anything within here. I will select the class of student. I'll change the font family to be Arial. I'll add a backup of sans serif in case Arial can't display for some reason. Let's change the font size to 2EM for 200%. I'll add a little bit of padding, 10 pixels. I'll add a border. Border, 1 pixel solid. Pick a color. I like HSL values. I'll set the transparency down a little bit to like 80%. Let's go with like 50% lightness. I'll remove any margin around the paragraph elements. We are accessing the class student, then access any paragraph elements. Margin 0. Okay, that's not too bad. So this is a student component to display some student data. We'll reuse the student component, but pass in different data each time. We'll create a new student component. This student's name will be Patrick. Patrick's age. Patrick will be 42. Is Patrick a student? Is student. I will set that to be false. Let's update our web application, and there is Patrick's data. Name, Patrick, age, 42, student, no. Let's add a few more. Student, name equals Squidward. Squidward's age will be 50. Is student. Squidward will not be a student. That will be false. Then let's add Sandy. She'll be the last student. Student name equals Sandy. Sandy's age will be 27. Is Sandy a student? She will be. That will be true. There we are. All right, we have created 4 student components. Each has different values depending on what we pass into props. We're going to move on to prop types. Prop types. Prop types are a mechanism that ensures that the passed value is of the correct data type. For example, within props, we have an age. We would like to ensure that the age value passed in is a number, not a string or a Boolean. If it isn't, then React can emit a warning within our console, mostly for debugging purposes. If you're working with props, it is good practice to also use prop types. So here's how to create prop types. After our student function, we'll type the name of the component, student, dot, prop types, equals, curly braces. Now we do have to import prop types. It's found within the node modules folder. Where is it? This should be in alphabetical order. There it is, prop types. At the top of our JSX file, we will import prop types from prop types, prop-types. Within our prop types, I would like to ensure that any name passed in is going to be a string. If it's not, we'll issue a warning within our console. Name, : space, prop types, dot string. Let's do this with age. Age will be a number. Age colon space prop types dot number. Then is student. Is student will be a boolean. Is student colon space prop types dot bool for boolean. All right, and those are our prop types. Heading back to our app component, for SpongeBob's age, if I don't pass in a number, let's say I pass in a string of 30, well, this won't prevent the program from running, but it will issue a warning within our console. If we right-click, go to Inspect, go to Console, we can see a warning. Failed prop type. Invalid prop age of type string. Supplied to student. Expected number. And here's a location. So this is good for debugging. It won't stop the application from running, just issue a warning. It is good practice to include prop types if you're accepting props. Then lastly, we're going to discuss default props. Default props are default values for props in case they are not passed from the parent component. Let's say we create a new student component, but we don't pass in a name. We can add a default value, such as guest, just in case that value isn't passed in one way or another. Okay, let's add default props down here. Student dot default props equals, set of curly braces, for the name, the default value will be guest. Age will be 0. Is student will be false. To test this, let's go to our app component. We'll create a new student component, but don't pass in any props. We'll create an empty student component with no props. That appears to work. The name is guest, the age is 0, student is set to no. So if I were to include a name, let's say name equals Larry. Well, Larry's name is going to be set. We didn't include any key value pairs for age or is student. We ended up using the default values, 0 and no. All right, everybody, so those are props. They are read-only properties that are shared between components. A parent component can send data to a child component. When you include a component, you can send that component key value pairs, which allows you to reuse that component but have unique data. And those are props with React. Hey, sup everybody. In today's video, I'm going to give you an introduction to conditional rendering in React. Conditional rendering allows you to control what gets rendered in your application based on certain conditions. By utilizing conditional rendering, we can show, hide, or change components. Here's an example. We'll create a user greeting component. Let's go to our source folder, new file, user greeting, and this will be a JSX file. I will be using function-based components. Function, the name of the component, user greeting. We will have one parameter, props. We learned about props in the last video. Before I forget, I'm going to export default the component name, just so that we can import it later. Heading back to our app component, we will return a user greeting component. User greeting. By using props, we'll send two key value pairs to our user greeting component. Is logged in. This will be a Boolean value. We'll check to see if we're logged in or not. And a username. Username equals, this is a string, so we do not need a placeholder. Type in your name or username. Then we do need to import user greeting. Import user greeting from a location // user greeting .jsx. Let's save everything, head to our user greeting component. We have these two key value pairs that are stored within our props object. I'll use an if statement to check to see if we're logged in or not. If props is an object, we will access props, followed by dot, is logged in. Is this true or not? If it is, then let's return an h2 element with text of welcome. I'd like to include some JavaScript. I'll use curly braces. Let's take props dot our username. Let's see if this works. Welcome, brocode, or whatever your name is. So what if we're not logged in? I will set is logged in to be false. Well, nothing appears to happen. Going back to our user greeting, let's add an else statement. Else we will return an h2 element with text of please log in to continue. Please log in to continue. Within our function-based component, we can check some logic using an if statement. If some condition is true, return this. If not, return something else. Now, technically, you don't need the else statement. You could just say return, because when you return, you exit. This would work too, as you can see. I don't think it's as explicit as using an else statement. Another option is to use the ternary operator, which we learned in JavaScript. We will return check props dot is logged in. Add a question mark. Is this true or is it false? If it's true, then we'll return an h2 element that says welcome. I'll add some JavaScript. Props dot username. I'm going to close this menu just so we can see. If this condition is true, return this. Otherwise, add a colon. We'll return something else. We'll add an h2 element. Please log in to continue. This statement is pretty lengthy. I'm going to put each part of the statement on a new line, just so we can read it easily. If is logged in is true, return this h2 element. If not, return this h2 element. Currently we're logged in. That is true. If I set this to be false, well, then we get that login prompt. Please log in to continue. You'll more commonly see people use ternary operators rather than if-else statements, just because they're more concise. Let's apply some CSS styling. Going back to our app component, we'll set is logged in to be true. We'll add a class name to each of these h2 components. Class name equals the first h2 element. If our condition is true, we'll have a class name of welcome-message. Our second h2 element will have a class name of login-prompt. Going to our CSS style sheet, let's select the class of welcome message. I'll apply the following CSS properties. Let's set the font size to be 2.5 EM. I'll change the background color. I like using HSL values. I'll go with this shade of green. Let's change the font color to be white. I'll add a little bit of padding, 10 pixels. I'll add a border radius to round the corners. Then set margin to be 0. Here is our user greeting component if the user is logged in. Let's style the login prompt class next. Dot login prompt. Really, I'll just copy these properties, but we'll change the background color. Let's change the background color to be red. All right, let's set is logged in to be false. Then our user greeting component should have those different CSS properties. Please log in to continue. If I set that to be true, well then we're logged in. Welcome, your username. Within our user greeting, this ternary operator is very verbose. Here's another way in which we can use the ternary operator in this situation. Let's create two constants. Const, the first will be welcome message. Be sure not to include any dashes though. Separately, we'll store these h2 elements. I'm gonna copy this first h2 element. We'll store that within our welcome message. Just so we can read it, I'm going to place each line on a new line. Then let's create another constant. Const login prompt. Be sure to eliminate any dashes. We will be using a camel case naming convention. Take our second H2, cut it, paste it, and there we go. I find that a lot easier to read. So we're going to take our condition, is logged in. If that's true, we'll return our constant, our welcome message. Otherwise, we'll return our other constant, our login prompt. And that will work still the same. Let's set that to be false. Please log in to continue. Set it back to be true. Welcome your username. I find this syntax a lot easier to read. Now, it is good practice if you're accepting props to set up prop types. Just in case the values that are passed in are not of the correct data type, you'll at least get a warning for debugging purposes. It's a good habit that we should develop. We learned about prop types in the last video. So at the top, let's import prop types from prop-types. After our function, take our user greeting component, dot prop types equals, take our keys, is logged in. The value with this associated key should be a Boolean. Prop, that's capital T, types, dot bool. Then a string for username. User name, prop types, dot string. All right, the last thing we're going to do is set up default props. What if somebody's logged in, but they don't have a username? We'll set a default for the username as guest. So after our prop types, we'll set up some default props. Again, take user greeting, that's the name of our component, dot default props equals is logged in will be false. And username will be guest if there's no username passed in. All right, going back to our app component, if a user is logged in, but there's no username, let's eliminate that. We'll get the welcome message of welcome guest. Now, if a user is not logged in, regardless, we don't display the username. All right, everybody, so that's conditional rendering. You can check some sort of condition. Based on if that condition is true or false, we can show, hide, or change components. There's many different ways in which you can do that. And well, everybody, that is an introduction to conditional rendering in React. Hey everybody, I have a huge video for you today. Today we're going to talk about rendering lists in React.js. This can be pretty complex. We'll go through it step by step. What we'll do in this tutorial is create a new component to hold our list. Let's go to our source folder, create a new file. I'll name this component list. This will be a JSX file. To finish creating this component, this will be a function-based component with the name of list. Then be sure to export it. Export default list. We'll start with something very simple. We'll create an array of fruit. This will be const fruits equals, think of some fruit. For me, I'll pick an apple, orange, banana, coconut, and a pineapple. Let me show you what would happen if we were to return our array. Within our list component, we will return our array of fruits, but we will need to import it. Going back to the app component, we will import our list component, import list from a location /list.jsx. We need a return statement. Be sure you have one. We will return a list component. And here's our list. Let me zoom in. It's all one big string. Apple, orange, banana, coconut, pineapple. Heading back to our list component, we need to convert our array of strings into an array of list item elements. we can use the built-in map method to do that. We'll create a new array of list items. The map method is going to return a new array after running it through a function. Const list items equals take our original array of fruits, use the built-in map method, then we'll either pass in a callback, a function expression, or an arrow function. We'll use arrow functions because I like arrow functions. For every fruit in fruits, arrow, meaning do this, we'll create a new list item element that has the text of our fruit, the array item. We're not going to return our fruits array. We're going to return an unordered list. We're going to insert some JavaScript with curly braces. We'll include our list items. It's an array of list items. And here's our array. Whoops, but I forgot to enclose fruit with curly braces. My mistake. There, much better. Or if you prefer, we can turn this unordered list into an ordered list with a pair of OL tags. OL. There, they're all numbered. That's how to render a simple array. If you're working with an array of strings and you'd like to sort this array beforehand, you can use the sort method. Fruits.sort. The sort method will sort an array in place. However, this doesn't work with numbers because we're sorting lexicographically. We would treat numbers and symbols as characters. More on that later. Let's go over example 2. We'll convert our array of strings into an array of objects. Each object will have a name property and calories per serving. So let's enclose all of our elements within a set of curly braces to make them objects. I'm going to place each of these objects on a new line just so that I can read it more easily. Each of these objects will have a name property. The name property will be set to the original string for our array. The first object will have a name of apple. Let's add calories too, calories per serving. I did a quick Google search of some of the calories per serving for these fruits. I don't know how accurate these are, but they seemed right. Our first object has a name of apple. The calories is set to 95. Name orange. Calories 45. Name banana. Calories 105. Name coconut. Coconut. Calories 159. Name pineapple. Calories 37. Alright, we now have an array of objects. There's a few changes we're going to make. If I run this again, our list isn't rendering. I need to display the name property of each fruit. Fruit.nameProperty. We have one issue behind the scenes. I'm going to right-click, go to Inspect, then go to Console. Warning, each child in a list should have a unique key prop. React wants us to assign a key to each list item. Each key should be unique. In my array of objects, each fruit has a unique name. I could use that. We will set the key attribute to equal, include some JavaScript, fruit.name. That warning should go away. Which it did. If there's a possibility that two objects can share the same name, you'll want to use some sort of unique ID. In a real-world scenario, if you're pulling data from a database, each row of data is going to have some sort of unique ID. So we're going to mimic that. Let's add a new property for an ID. ID will be 1 for apple. These will be in ascending order. Orange will have an ID of 2. Banana is 3. Coconut is 4. Pineapple is 5. We'll set the key to be each ID. This would be much better than using the name. You can have a naming conflict if two objects share the same name. Like if these were people, you could have two people named Bob. that warning should be gone. Which it is. React would like a unique key for each item, just so it can more easily keep track of items being inserted and removed. Along with each element, I'm going to display the calories next to each element. So we'll make a few changes. I'm going to put these HTML elements on a new line for readability. After the fruit's name, I'm going to add a colon, a non-breaking space character, ampersand, NBSP for a space. Oh, then add a semicolon. Forgot about that. Then we'll insert some JavaScript. Fruit.calories for the calories of each fruit. I'll make it bold. I'll enclose our calories with a pair of bold tags, which is just B. Now we're going to sort the items in our list. We'll do that before the map method. I'm going to sort our array of objects by their name property. We'll take fruits, use the sort method. The sort method will sort an array in place. We'll write a custom sorting function. We have two parameters, A and B. A for the first item, B for the second. Then we iterate over the entire array. We need an arrow, meaning do something. To lexicographically sort string properties within an array, we can use the following method. We'll take the name property of A, use the built-in local, or locale, some people say, compare method. I misspelled that. Yeah, I can't spell. Compare to b.name. That should sort our array of objects by their name property. For reverse order, let me turn this line into a comment. This is alphabetical. For reverse alphabetical order, we just have to replace A with B and B with A. There. Pineapple, orange, coconut, banana, apple, with apple being at the bottom. Let's sort by calories. Fruits.sort. This one's easier. Again, we have our parameters, A, B. Arrow, the calories of A.calories, minus B.calories. That one's easy. We have pineapple at the top, followed by orange, apple, banana, coconut. This is in numeric order. For reverse numeric order, reverse numeric, or descending, you could say, the calories of B minus the calories of A. Now we have coconut at the top, with pineapple at the bottom, with the least amount of calories. In this next section, I'm going to demonstrate to you how we can filter objects by a certain criteria. We'll filter anything that's greater than 100 calories. We'll create a new array of fruit that has low calories. We'll create a new array, const low cal fruit equals, take our original array of fruits, use the built-in filter method. We'll have one parameter of fruit, examine each fruit in our array of fruits, arrow, then a condition. Here's the criteria. Check the calories property of our fruit. If it's less than 100, filter it and add it to a new array. Instead of displaying our array of fruits, let's display our new array of low-calorie fruit. Oh, that should be plural, low-cal fruits. When we create our array of list items, replace fruits with low-cal fruits, and any instance of fruit with low-cal fruit, singular. So we have 3 instances of fruit. Let's replace those. Let me clean this up a little. Feel free to pause the video if you need to write this down. We have 3 fruits that are low calories. The calories is less than 100. Let's find any high-calorie fruits. We can just copy this line of code, paste it, but change the condition. Examine the calories of each fruit, filter it out if the calories are greater than or equal to 100. The name of this array will be high-cal fruits. Replace low-cal fruits with high-cal fruits. Replace low-cal fruit with high-cal fruit, singular. And do that for the other instances as well. There we are. We have two fruits that are high in calories, bananas and coconuts. That is us using the filter method to filter out list items. Let's replace high-cal fruits with fruits, high-cal fruit with fruit, to display our original array. For the next part of this lesson, we're going to transform this list component so it's reusable with different lists. Currently, the way that we set this up is that each list component that we create has its own list of fruit. So we're going to make some changes. Let's cut our list of fruits, going to the parent component of app. We'll paste our list of fruits, then pass it as props to our list component. With our list component, we will have a key of items equals, insert some JavaScript, our list of fruits. Let's also add a category key. Category equals, for my category, let's say fruits. Eventually, we'll add an H3 heading. We're now going to send all of this data to the list component, but we have to set up props. Within the list function, we have a parameter of props. We'll access the items of props to get our fruit. We'll create const item list equals, not to be confused with list items. List items is what we get after we map it. Item list equals props.items. And remember that items is our fruits array. Replace fruits with item list. Replace fruit with item. Do that here, here, and here. There's our list again. If you're going to sort or use the filter method, be sure it's item list, not fruits, because now list is a reusable component. I'll add our category too. That's stored within props. Const category equals props.category. Currently, we're returning a single ordered list. I'll also include an H3 element. Include some JavaScript, we need curly braces, add our category. However, with our return statement, we can only return a single element, or many elements that are wrapped within a fragment. Let's create a fragment that will enclose all of our markup. There we are. Going back to our app component, let's create a new list, just to make sure that our list component is reusable. Let's copy our array of fruits, paste it. We'll create an array of vegetables. The IDs will be 6, 7, 8, 9, 10. The name of my first item will be potatoes, calories 110 per serving. Celery, calories will be 15. Carrots, calories 25. Corn, calories 63. Broccoli, calories 50. Now we should be able to create a new list component. Within our return statement, we're going to need a fragment again. We'll return a second list item component. The items will be vegetables. The category will be a string of vegetables. Boom, there we go. Here's our second list component. So our list component is now reusable. We can pass in many different types of lists. To make this look better, let's apply some CSS styling. We'll have to set a class name first. Our H3 element will have a class name equal to list-category. Our ordered list will have a class name of list items. Alright, going to our CSS style sheet, index.css, let's work on our list category first. Use dot to select a class, list category. I'm just going to run through these real quick. I'm going to make sure I'm zoomed in to 100, because I was zoomed in beforehand. Font size, 2.5 EM. Font weight will be bold. Pick a color. I'm going to stick with HSL values. I'll set the lightness to be 20%. I'll add a little bit of margin on the bottom. 10 pixels. Text align center. I'll add a border. 3 pixels solid. I'll add a border radius to round the corners. And a background color. Pick a color. Again, I'll use HSL. This one I pre-picked already. 185, 100%, 50%. That's not a bad looking color. Pick whatever color you would like. Let's work on our list item elements. We need to select the class of list items. Dot list items. Select each list item within this class. I'll increase the font size to be 2 EM. I'll remove the list style, but you don't have to. List style will be none. Pick a color. Again, I'm using HSL values. I'll set the lightness to be 25%. Text align center. And margin will be 0. Alright, now when I hover over one of these list items, I'll apply a hover effect. Take our class, list items, take each list item, access the hover pseudo class. I'll change the brightness. The color will be something a little bit brighter. I'll set the lightness to be 45%. And then the cursor will be a pointer. Yeah, not bad. That's how we can apply some CSS styling to list components. Alright, heading back to our app component, what if we have an empty list? For example, with our fruits, I'm going to cut it. We can use conditional rendering to render our list only if there's elements. Let's put those back. We're going to write some JavaScript. We need some curly braces. Let's take our array of fruits, access the length property. Is it greater than 0? Question mark. If it is, we'll return our list component. Colon. If it's false, we can return null. Let's do that with our vegetables too. Take our array of vegetables, access the length property. Is it greater than 0? Ternary operator. If it is, return our list component. If not, we can return null. If one of these lists doesn't have any elements, we won't render that component. There is a shorthand to the ternary operator. We don't need to write, or else return null. What we'll use instead of the ternary operator is the AND logical operator. We can effectively short-circuit the first expression. Then we don't need colon null. It's a little less code. Our list component will always be true, because it exists. However, the first expression might not be. So if this condition is false, we don't render this. If it is true, we will render this. Let's try that again. Let's remove these elements. We don't display the fruits list component, and we will not display the vegetable list component. This is known as short-circuiting. One thing to consider, what if our category is missing? Let's remove our category from fruits. Well, I would like to add some sort of placeholder here. Or what if one of these arrays was missing? Well, nothing displays, not even vegetables. We should add some default props, in case one of these properties is missing. So, going back to our list component, before we export it, let's set up some default props. Take our component name, list.default props equals, within a set of curly braces, let's set our category property, to be category as a placeholder. If for some reason these components don't have a category, we'll add a placeholder of category, which at least looks better. If we're missing an array, that's a bigger problem. Let me go to inspect, then console. We're trying to map something that's undefined. We have no array to work with. So nothing is rendering. So as a backup, within default props, let's set our items to be an empty array. Items will be an empty array. If one of these arrays was missing for some reason, at least the category is displayed, as well as the subsequent components. At least something will display. Okay, then lastly, as good practice, if we're accepting props, we should set up prop types. I'll walk you through it. If you're just joining us with prop types, if the incorrect data type is passed into props, when we debug, it'll give us a warning. To use prop types, we have to import it. At the top of our list component, we will import prop types from prop types. Take our component of list.proptypes equals, set of curly braces. For our category, this will be a string, category, :space, proptypes.string. Add a comma for another line. Okay, this is where it's going to get tricky. We have an array of objects. We'll access the items property, items, :space, prop types. I'm going to move down a little bit. Dot, we have an array. We have an array of objects. Prop types dot shape method. We have to define the shape of each object. Each object is going to have its own data types. We have a number, string, then number. We're defining an object. We need a set of curly braces. ID, prop types dot number, comma, for another property. I'll put the next one on a new line for readability. We have a name property, which will be a string, prop types dot string, then calories, prop types dot number, and that's it. Let's head back to our app component. Our prop types should raise a warning if some of our data is of the wrong data type. For example, let's say that calories is now the string apple. Maybe somebody mistyped it twice. You can see that right here, it changed. Let's go to inspect, console, and here's our warning because we have prop type set up. Invalid prop items, index 0, calories of type string. If we didn't have prop type set up, we wouldn't receive that warning. This may go unnoticed. It is good practice if you're accepting props to also set up prop types. It's a little more complicated if you have an array of objects, but here are the steps. Alright everybody, I know this was a massive topic. Thank you all for watching. Feel free to take some time to study and work with this before moving on to the next topic if you would like. We did cover a lot of material. And well, those are various ways in which we can render lists in React. Hey, so today I'm going to explain click events and how to handle them in React. A click event is an interaction when a user clicks on a specific element, we can respond to clicks by passing a callback to the onClick event handler. In this example, we'll create a button. Let's create a button component, go to New File, button.jsx. We will use a function-based component, function button, then be sure to export it. Export default button. Going back to our parent component of app, we will need to import our button. Import button from its location, button.jsx. Then we will create one button component. Going to our button component, we will return a single button element. The button will have text of "click me." Hey, for fun, I'm just going to add an emoji, but you don't have to. And I will zoom in so you can see it. Many HTML elements have an onClick event handler. We can set this equal to a JavaScript callback, but we need a function to work with. So within our button function, we can write an inner function. Const handle click. I will assign this equal to either a function expression or an arrow function. I like arrow functions, so I'm going to stick with an arrow function. When we click on the button, what do we want to do? Let's console.log the word ouch. So we have our function. We will set the onClick event handler equal to a callback to this function. When we click on the button, do this. If I went to my console, inspect, console, let me refresh this. If I click on the button, we execute this code. We will output the word ouch every time I click the button. If your function has parameters, there's one change we'll need to make. Let's create a second function. Const handle click to. This function will have a parameter of name. We'll use an arrow function. We will console.log. I'll use a template string. Let's display the name. Stop clicking me. For the onClick event handler, we will set a callback of handle click to. But we have parameters. That means we need to send a matching number of arguments. I will send my first name, but feel free to use your name. I didn't click on the button yet. I'm going to go to inspect, console. Let me refresh all this. I didn't click on the button yet, but we've already called that function. If you add a set of parentheses after a callback, you'll invoke it right away. So we don't want to do that. If we have arguments we need to send to a function, we could wrap this callback within a function expression or an arrow function. Let's use an arrow function. When we click on the button, do this. That will prevent us from calling this function right away. So let's refresh everything. Then when I click on the button, then we execute this code. Bro, stop clicking me. Bro, stop clicking me. Bro, stop clicking me. So that's how to send arguments to a function. Now, in this next example, we'll add some conditions. Let's set the onClick attribute to be a callback to handle click. If you have more than one line of code for your arrow function, you'll need to use a set of curly braces. Let's add a count variable. Let count equal 0. With our handle click function, let's have one parameter, a name. What would we like to do? Let's check to see if our count variable is less than 3. If it is, let's increase count by 1. Then console.log, I'll use a template string. Let's add our name parameter. You clicked me, add a placeholder, count, time, or times. Else, if the user clicked me more than 3 times, let's console.log a different message. Let's say, add a placeholder, name, stop clicking me. With the onClick event handler, We have a parameter. That means we have to wrap this callback within a function expression or an arrow function. Let's use an arrow function for simplicity. We'll pass in a first name. Pass in your own first name. So let's save and refresh everything. Go to Inspect, Console. When I click on the button once, it's going to display, bro, you clicked me 1 time. Bro, you clicked me 2 times. Bro, you clicked me 3 times. After the 3rd time, we'll display a different message. Bro, stop clicking me. Bro, stop clicking me. Bro, stop clicking me. So within your functions, you can write some conditions. Now I need to explain the event parameter. Let's recreate that handle click function. Const handle click equals with click events were automatically provided with an event argument. It's an object that describes the event that occurred, but as a parameter, people usually shorten the event parameter to be simply e. Let's print our event. Console.log e, our event. We'll need to set the onClick event handler. We have 1 parameter, so we need to wrap this within an arrow function. Handle click. For the arrow function, we'll have e for the parameter and e for an argument for the handle click function. Let's click on the button. We're now outputting the event. Its type is synthetic base event, and it has all of these properties and methods, such as where you clicked on the screen, there's a timestamp, and a target. By utilizing this event object, that gives us many different possibilities. For this demonstration, let's change the text content of the button. So there should be a target property here. I am going to change the text content. That should be a property. Yep, there it is. So what we'll do, after clicking on the button, we will access that event object. Follow this with dot, that's the property accessor. We're selecting the inner target object, then selecting the text content property. Let's set that equal to be ouch. So now, when you click on the button, the text of the button should change to ouch. I'm going to add an emoji too. There we go. Okay, let's try this again. This will be fun. Click me. Ouch. There's also the on double click event handler. Instead of on click, you'll say on double click. So when we click on the button once now, nothing happens. But once I double click, that's when we'll execute this function. Now I'm going to double click. Ouch. If you need to handle a double click, you just have to use the on double click event handler. Alright, let's move on from using a button. This time, let's use an image. In my assets folder, I do have my profile picture for my YouTube channel. Find a profile picture of yourself or a picture you like. We're going to create a new component. Let's go to our source folder. I will name this component profile picture.jsx. We will create a function with the name of profile picture. Then be sure to export it. Export default profile picture. Then going back to our app component, we will import our profile picture component from its location. Profile picture.jsx. Let's include our profile picture component instead of our button. Alright, so within our profile picture component, I will store a URL within a constant. Constant image URL. I will list a relative file path. So my image is within my assets folder. My file location, but it might be different for you. Mine is going to be ./source/assets/ the name of the image, including the extension. Mine is profile.jpg. We will return an image element. IMG for an image element, I will set the source equal to some JavaScript. I need to set a curly braces. I will set it equal to my image URL. And let's see if that worked. Yes, it did, but I'm gonna zoom out to like 150. My image is small. Let's add a handle click function. Const handle click equals an arrow function. To test it, let's console.log the word ouch. Then we'll need to set the onClick event handler within our image. OnClick equals a callback to handle click. So let's save and refresh everything. Let's go to inspect console. When you click on your image, it should display the word ouch every time you click it. Let's utilize the event object that's generated. We have one parameter, E for our event. That means we'll have to change the callback to be an arrow function. E for the parameter, arrow, handle, click. We have one argument of E. So what should we do now? When we click on the image, let's hide the image. We'll need to access that event object, access the target object that's found within, access its style, then the display property. We will set the display to be none when we click on it. So then, if you were to click on your image, it should disappear. So by accessing the event object, that gives us a load of different possibilities for what we can do. Alright everybody, so that is an introduction to handling click events in React. A click event is an interaction when a user clicks on a specific element. We can respond to clicks by passing a callback to the onClick event handler. And well everybody, that is an introduction to click events in React. Hey, what's going on everybody? In today's video, I'm going to explain the useState React hook. And near the end of this video, we're going to create a reactive counter program. So sit back, relax, and enjoy the show. I haven't explained what React hooks are yet. A React hook is a special function that allows functional components to use React features without writing class components. This was a change made in React version 16.8. Basically, we no longer need to write class components. We can write function-based components that use React hooks to use React features. There are many React hooks. If a function begins with use, it's probably a React hook. UseState, useEffect, useContext, useReducer, useCallback, and more. UseState is the most widely used. UseState is a React hook that allows the creation of a stateful variable and a setter function to update its value in the virtual DOM. Basically, by using the UseState hook, we can create not just a variable, but a stateful variable. When you update this variable, that change will be reflected in the virtual DOM. Normal variables don't. When you use the useState hook, you're given a variable and a setter function specifically for that variable. So what we'll do in this example is create a new component. Going to our source folder, we're going to create a new file. We'll name this component my component. We use React hooks in function-based components, so make sure you're not writing a class component. With this component, we will export it, export default my component. Then be sure to import this because I'm probably going to forget if we don't do it now. So we will import my component from its location, /my component. And this is a JSX file. Let's return one my component. And we are ready to begin. In order to use a React hook, we need to import it. At the top of this component, we will import the React library. However, we don't need the entire React library. We can use object destructuring to extract individual variables or functions. I would just like the useState function. We don't need the entire React library. From its location, React. We now have access to this useState function. Using the useState function, we'll create a stateful variable and a setter function to update that variable. So let's declare const. We're going to use a set of straight brackets for array destructuring. Equals useState function. The useState function returns an array with two elements, a variable and a setter function. We're going to use array destructuring to destructure these two elements. We'll create a stateful variable for name, then we're given a setter function specifically for this variable. A common naming convention is to type set, then the variable name with camel case naming convention. And that's it. If we ever need to change the value of the stateful variable, we have to do so with this setter. It's a function. At the bottom, we're going to return a div element. Within this div element, we'll create a paragraph element and a button. We'll begin with the paragraph element that has text of name. And I'm going to zoom in a little bit. I will insert some JavaScript using curly braces. Let's display our name. Following our paragraph element, let's include a button. The button will have an onClick attribute equal to a JavaScript function. So we need a set of curly braces to embed that. Let's create a function to update name. For the text of the button, let's say set name. All right, now we just need to declare this function. I'll use an arrow function. Const update name equals arrow function. So what would we like to do? Okay, let's attempt to set our name equal to, type your name or some other name. I'm just going to type in SpongeBob. If I click on this button, we should update our name, right? Well, that doesn't appear to work. So if I were to console.log my name variable, then attempt to update it using this button, if I were to go to my console, hold on, I'm going to use let so we can update it. If I attempt to change this name of the variable, it does so within our console, but it doesn't update in React. The virtual DOM is still displaying the previous state. So if I would like to display any changes, I will want to use that setter. Instead of setting our name equal to a new value, I'm going to change this back to be a constant. We will use the setter function and pass in a new value. So let me type in a new value. And that should work. We have updated our name. When you use the setter function of a stateful variable, it will trigger a re-render of the virtual DOM. Normal variables don't. That's why the useStateReact hook is useful. We can create a stateful variable. When the stateful variable gets updated with its setter function, it triggers a re-render of the virtual DOM. With the useState function, you can pass in an initial state. Currently, we're not passing in anything. For the initial state, I will set this to be guessed. When I refresh everything and start over, the initial state is guessed, whatever value you pass in to the useState hook. Then I can set my name again to something else. Now we're going to create an age variable and increment it. Const, we're going to use array destructuring. We need a stateful variable, like age, and a setter function for that age. Set age equals use state. If you would like an initial value, you can place that within the useState function. I'll set the initial value of age to be 0. I'm going to copy this paragraph and this button. Change name to be age. We'll create a function to increment age. The text on the button will be increment age. Now we just need this function. Const increment age. I'll use an arrow function. To increment our age, we will use the setAge function. Let's take our age plus 1. So our initial value for our age is 0, but every time I click on the button, we will update the value of that variable. So every time I click the button, we're increasing our age by 1. Or even a different number. This time I'll increase our age by 2 on each button click. So we start at 0, then we'll increment by 2. 2, 4, 6, 8, 10. Now this time, we'll create a Boolean variable and toggle it between being true and false. Using the useState hook, we will create const is employed. The setter function will be set is employed. equals the use state hook. I would like an initial value of false. Let's create a paragraph element and a button. I will set the text of the paragraph to be is employed. Instead of displaying a Boolean directly, let's use the ternary operator for conditional rendering. Is employed. If that is true, we'll display yes. Otherwise, no. When we click on the button, let's create a function to toggle employed status. That's kind of a long function name. All right, let's create a function, const toggle employed status equals an arrow function. We will use the setter function, set is employed, pass in a new value. Let's switch this value from being false to true and true to false every time we click the button. Since this is a Boolean, we can use the not logical operator to reverse it. So let's say not is employed. And let's see if this works. Is employed. Nope. Oh, let's change the text on the button too. Toggle status. There we go. All right. When we click on the button, we can toggle this Boolean from being true to false and false to true. And this should happen every time I click the button. As a project, what we're going to do now is create a counter program. So let's close out of my component. We'll create a new component for a counter component, counter.jsx. This will be a function-based component, function counter, then be sure to export it. Export default counter. Going back to our app component, we will import our counter component from its location, counter.jsx. Then we will include one counter component, and that's it. In order for us to use the useStateHook, we have to import it from the React library. Import React will use object destructuring just to get the useStateHook and nothing else from its location of React. All we need is one variable, a counter. Let's say const. We'll use array destructuring, create a stateful variable of count, and a setter function for that count. Set count equals the useStateHook. Would we like an initial value for count? We would like the initial value to be 0. We'll create a few functions to increment, decrement, and reset the counter. Const increment equals, I'll use an arrow function. To update the count, to increment it, we will use the set count function. The value we'll pass in is count plus 1. Then let's do this for decrement. Const decrement count minus 1, then reset. Const reset. For set count, we'll pass in 0 to reset the count. Now we're going to return some elements. We'll also style this with CSS. Let's begin with the div element. I'm going to scroll down a little bit. My div element will have a class name equal to counter-container. I will create a paragraph element with a class name equal to count display to display the number. For the text of the paragraph, I will insert some JavaScript and display our count variable. We'll create 3 buttons. For the first, we'll create a button element. This button will have a class name of counter-button. The onClick attribute will be set equal to a JavaScript function. This first button will be the decrement button. For the onClick attribute, we will set this equal to the decrement function. For the text on the button, we'll say decrement. And there's our first button. So let's copy this button, paste it, The second button will be for reset. The text will be reset. Then the third button will be increment. OnClick will be the increment function. The text will be increment. All right, and that's all that we need. Let's check it for functionality to be sure that everything works. We can increment this number, we can decrement it, and we can reset it. So for the icing on the cake, let's style it with CSS. Going to our index CSS style sheet, we'll apply the following CSS. Let's select our counter container. Dot counter container. I will text align center. Change the font family. I will pick a sans serif font of Arial with a backup of sans serif. Next, we'll select the count display. Select the class of count display. That would be this number. We'll increase the font size to something massive, like 10 EM. REM works too. Okay, that's a little too big, but I am zoomed in. Actually, you know what? That's perfect. I will set the margin top to be 0 to close this gap. And I will set the margin on the bottom to be 50 pixels. Then let's work on the counter buttons next. Select the class of counter button. I will set the width to be 150 pixels. The height to be 50 pixels. The font size to be 1.5 EM. I will set the font weight to be bold. Set the margin to be 0 pixels by 5 pixels. This would be for the left and right of the buttons. Change the background color. Pick a color that you like. I'm going to use HSL values, though. That's pretty good. I will set the color of the font to be white. Remove the border. Border, none. Set the border radius to round the corners. 5 pixels. And change our cursor to be a pointer if we hover over the button. When we hover over the button, I'm going to change the background color of the button. So with the counter button class, we will select the hover pseudo class. We'll take our background color, decrease the lightness to be 10% darker. There we are. And that is all the CSS styling that we need. We have our counter program. We can increment the counter, we can decrement it, and we can reset it. Alright everybody, so that is the useState React hook. It allows the creation of a stateful variable and a setter function to update its value in the virtual DOM. When you include the useState hook, you're given an array of 2 elements. We use array destructuring to create a stateful variable and a setter function to update that variable. And well everybody, that is the useState hook in React. Yo, what's going on, people? So today I gotta explain the onChange event handler in React. onChange is an event handler used primarily with form elements, including but not limited to input, text area, select, and radio buttons. onChange triggers a function every time the value of the input changes. So let me give you an example. We will be using the useState hook, so we need to import it. Import React. I would like the useState hook from React. Using the useState hook, we're going to create a name variable, a stateful variable, const name, and we need a setter function for this variable. Set name equals the useState hook. You can set an initial value. I'll set mine to be an empty string. I will be returning a div element to enclose all of our markup. Within my div element, I will create an input element. And here's my input element. I will set the value of the input element to be some JavaScript. my stateful name variable. Then I will set the onChange event handler to be a reference to a JavaScript function, which we still need to create. This will be a callback. Let's create a function to handle a name change. It's going to be similar to handle click. Function handle name change. We have one parameter, an event. That's going to be provided to us. When we change the value of this input element, I will invoke our setName function. We will set our name variable to be access our event object, access its target, then get the value property. OnChange is going to be set equal to a callback to this function. When we type something or somehow change the value within here, call this function. And then afterwards, I will include a paragraph element that has the text of name and include some JavaScript. I will include my name variable. So what should happen is when I type in a name, it will update in real time. With useState, I can set the initial value to be something too. I'll set my initial value to be guessed. The onChange event handler triggers a function every time the value of the input changes. Right now we have an initial value. If I start deleting this, my name is going to update. This time, we'll create an input element for a number instead of text. I will create a stateful variable for a quantity, as if we're ordering something. Quantity, and we need a setter function. Set quantity equals the useState hook. Would we like an initial value? Not yet, but we'll get to that later. I will create a function to handle quantity change. It's the same formula as before. We will be provided with an event, so let's write a parameter for that. We will use the setter function for the quantity. Set quantity. We'll pass in access our event, access its target, then access its value. Then we need some HTML elements. Let me scroll down. I will create an input element. I will set the value of this element to be our quantity. Then I will set the onChange event handler to be a callback to a JavaScript function. Handle quantity change. I will set the type of this element to be a number. Type equals number. Afterwards, I will add a paragraph with our quantity and display our quantity variable. So now we have arrows to select a number. I will update the quantity to be 1, 2, 3, 4, 5. I'll set an initial value of 1. Let's pretend that we're ordering something. We're going to assume that the user wants to buy at least one of something. That's how you can use onChange to reflect a number that's changing within an input element. Alright, now we're going to create a text area. A user is going to be buying something. We'll have a user leave a comment. I will create const comment. Set comment equals useState. I'll set the initial state of my comment to be an empty string. Then I'll create a function to handle comment change. Function handle comment change. We have one parameter, an event. We will use our setter for our comment. Then pass in, access our event, access its target, then access its value. Then we need our HTML elements. We will create a text area element. I will set the value to be our comment variable. Then set the onChange event handler to be a callback to handle comment change. I'm also going to add a placeholder for some placeholder text. Placeholder holder equals, in my specific example, this text area will be for specific delivery instructions. If somebody's shopping on your site and they order something, they might want to provide additional delivery instructions. Leave package on the back porch, ring the doorbell after the delivery is complete, stuff like that. So for my placeholder, I'll type in enter delivery instructions. And there's my placeholder text. Then, just to see if this updates, I'll add a paragraph element with my comment, then insert my comment variable. All right, let's see if this works. Leave package on front porch and avoid the killer chihuahua. That's how we can use onChange with a text area. All right, the next one's going to be a little more complicated. We're going to use a select element for a drop-down menu. We'll create a drop-down menu for a payment. Is somebody going to pay with a Visa, a MasterCard, a gift card? Const payment set payment. This will be a payment type. We'll use useState. I will set the initial value to be an empty string. Then we need a handler function. Function handle payment change. We have one parameter, an event. Then we'll use that setter function for the payment. Set payment, event, access its target, then the value. Our select element has a pair of tags. We'll place option elements within our select element. The opening select element is going to have a value equal to our payment variable. I will set the onChange event handler equal to a callback to the handle payment change function. We have some options within our select element. The text on my first option will be select an option. So now my drop-down menu has select an option. For this option's value, I will set it to be an empty string. This will be the default. Let's create another option. The text on this option element will be a Visa, if somebody's paying with a Visa card. The value will be a string of Visa. Besides the defaults, we do have an option for Visa. Then MasterCard. MasterCard. The value will be a string of MasterCard. And then a gift card. Gift card. The value will be gift card. So besides our default, we have Visa, MasterCard, and gift card. After our select element, I'll create a paragraph. The text on the paragraph will be payment. Then I'll display our payment stateful variable. When I select Visa, our payment is going to update with Visa, MasterCard, and gift card. With useState, I can even set an initial value. I could set the initial value to be, for example, Visa, MasterCard, or a gift card. But I'll keep it as an empty string so we get that default text of select an option. The last form element I'll cover is radio buttons, and these are going to be the most complicated. We'll create a pair of 2 radio buttons for a delivery method, either pickup or a delivery. Does somebody want to come into a store to pick up our package, or is a driver going to take it to their residence? I will create const, let's say shipping, for the shipping method, and a setter function for set shipping equals use state. For the time being, I will set the initial state to be an empty string. We'll create a handler function. Function handle shipping change. We have one parameter of event. I will use that setter function of set shipping. access our event argument, access its target, access its value. Within our HTML markup, we're going to create a pair of radio buttons. We'll create a label. We need a pair of label elements. The text on the first label will be pickup. Are we going to pick up our package from a store? We'll create a second label. I'll just copy what we have, paste it. The second label will be for a delivery. Within my label, I'll create an input element. I will set the type to equal radio. I will set the value of this radio button to be pickup. I'll place these additional properties on a new line just for readability. I will set the checked attribute equal to a JavaScript expression. Let's check to see if our shipping stateful variable is strictly equal to our value of pickup. This will evaluate to be true or false. If this expression is true, then we'll trigger our onChange event handler and set it equal to a JavaScript function. It's going to be a callback to handle shipping change. Let's copy this input element, then within our second label, paste it. But we'll change our value to be pickup to delivery. Within our checked property, check to see if shipping is strictly equal to delivery. If this expression is true, then checked will be true. This will trigger the onChange event handler. Just to reflect the change, I'm going to add a paragraph element with text of shipping. I will insert some JavaScript. I will insert our shipping stateful variable. I'm going to add a break after our first label just for readability. I think that looks better. If I were to select pickup, the shipping method changes to pickup. We're going to pick up our delivery from a nearby store. If I change it to delivery, the shipping method changes to delivery. With the useState hook, we can set an initial state. Let's assume that if somebody is ordering something from our site, they will want it delivered. I will set the initial state to be delivery. And that did update. But if somebody does want to pick it up, they can easily just change that by selecting this radio button. All right, everybody, so that is the onChange event handler. It's used primarily with form elements, including but not limited to input, text area, select, and radio buttons. OnChange triggers a function every time the value of the input changes. So, for example, if I were to type in my name into this input element, that change is immediately going to be reflected in real time. And well, everybody, that is the onChange event handler in React. Hey, what's going on, everybody? In today's video, we're going to create a color picker program using React. This serves as more of an exercise now that we know how the useState hook and the onChange event handlers work. So let's get started. All right, let's begin, everybody. Within our source folder, we'll create a new file for a color picker component. This will be a JSX file. We will use function-based components. Function, color, picker. There are no parameters. Then let's be sure to export this. Export default color picker. We need to return something. For the time being, I'm going to return a fragment, just so that everything works. Going back to our app component, we will import our color picker component from its location. /colorpicker.jsx. Then let's include one color picker component. And that is all we need with the app component. Heading to the color picker component, we will need to import the useState hook. Import from React. We'll use object destructuring just to get the useState hook from React. Within our color picker function at the top, we'll use the useState hook to create a stateful color variable. Const, we're going to use array destructuring and create a color and a setter function for that color. We will use the use state hook. For the color, if you would like to set an initial color, you can do that. I recommend using hexadecimal values to keep it simple. For example, if you would like white, that would be 6Fs. Personally, I'm a fan of using HSL values for hue, saturation, and lightness, but that can get kind of complicated. You would need to pass in a JavaScript object with those three properties. We'll stick with hexadecimal values just to keep it simple. Then we'll create our HTML elements. So within the return statement, I will create a div element. This div element will have a class name of color picker container. With React, when using CSS, I like to use a hyphenated naming convention. This div element will contain everything we need for our color picker component. Within this div element, I will create an h1 element for a heading. The heading will be color picker. After this h1 element, I will create a nested div element. This nested div element will have a class name equal to color-display. This is what's going to change color, this div element. Now, I will set the style attribute equal to some JavaScript. If I attempt to set the background color to our color variable, well, with any CSS properties in JavaScript, we need to enclose them within an object. So we will use a double set of curly braces. And that would work. If you're embedding some JavaScript, and then you're changing some CSS properties, you'll need to enclose those CSS properties within a JavaScript object. Within this nested div element, we'll create a paragraph element that has text of selected color, embed some JavaScript, include our stateful color variable. After this div element, I will create a label. This label will have text of select a color. I'll create an input element. Input. The type attribute is going to be color. We'll have an input element for a color. The default is black. I'll set the value equal to our stateful color variable. Then to change the color, I will set the onChange event handler equal to a callback to a function. We will handle color change, but we still need to define this function. That's the last step in this component. So we will create a function to handle color change. There will be one parameter, an event. All we're going to do is use our setter function for our color. Whichever color we select, that's going to be its value, either RGB, HSL, or hexadecimal. We will access this event, target, access its value. Set the color to whatever that value is. So if I set the color to be, I don't know, blue, well, that color is going to change to be blue. And that is everything we need for this component. We haven't applied any CSS yet, so it's not very impressive, although it does have functionality. So be sure to save everything. We will go to our CSS style sheet. Let's select the body of our document. I will set the font family to be Arial with a backup of sans serif. I will take our class of color picker container. This is what contains everything, this div element. Take our color picker container. I will use flexbox because I like flexbox. Display flex. Flex direction will be a column. Right now it's a row. And align items in the center. Much better. Let's take our h1 element, that would be this heading. We are selecting h1. Let's add some margin of 50 pixels. And increase the font size to 3 rem. Let's select our color display, that would be this element right here. that has a class of color-display. I will set a width of 300 pixels, a height of 300 pixels. I'll use Flexbox for all the elements within, display flex, justify content in the center, then align items center. I'll add a border around this element. Border 5 pixels solid. I'll use HSL for the color. Let's pick something light gray. I'll set the lightness to be 80%. Then I'll round the corners with border radius. Border radius 25 pixels. I'll add a little bit of margin to the bottom. Margin bottom 25 pixels. So when we select a color, it's going to change. I'm going to add a transition effect, so the transition is a little more smooth. I will set the transition property. After a quarter of a second, 0.25 seconds, we will ease this transition. So this animation should be more smooth. Let's select this paragraph element and style it. Take our color display class, access the paragraph element within. For the color, I'll use HSL values. 0, 0%, then 20%. This will make the text a dark gray color, although it's kind of small, you can't really see it. I'll increase the font size to 2 rem. Then text align center. Let's work on the text of the label. We're going to select our label, increase the font size to 1.5 rem. Let's set the font weight to be bold, and add a little bit of margin to the bottom. Margin bottom 10 pixels. The last thing we need to do is change this input element so it's a little bigger. I will select our input element, but I don't want to select all input elements. I'll use an attribute selector. Select all input elements that have a type of color. So that'll be just this one. I will set a width of 75 pixels, a height of 50 pixels, some padding of 5 pixels. I'll set a border radius to round the corners of 10 pixels, then set the border to be 3 pixels solid. And for the color, I'll use HSL. 0 for the hue, 0 for the saturation, 80% for the lightness. That should give us a thick gray border. Alright everybody, so that is a color picker program you can create as an exercise for React. Yo, what's going on everybody? So in today's video I gotta explain updater functions in React. An updater function is a function passed as an argument to set state, usually. For example, I have a setter function for a year. If I need to increment my year by 1, I would just add +1 to year. This does in fact work, but a better practice would be to pass in an updater function as an argument. Usually this is represented as an arrow function. By passing in an updater function, this allows for safe updates based on the previous state. You typically see updater functions used with multiple state updates and asynchronous functions. It is a good practice to use updater functions whenever possible. So in this basic example, I've made a counter program. We can increment count, decrement count, and reset count. Within each of these functions, I'm taking my state variable of count, adding +1, -1, or setting count to equal 0 in the case of reset. I don't want to increment once, I would like to increment twice. I will take set count, update the state again, using count +1. This is different from me adding 2 to count. I want to increment count by 1 twice. I will set the state of count twice. Count plus 1, then count plus 1. If I attempt to run this, I will increment count twice with every button click. However, our count only increases by 1 during each button click. I'm very persistent. Let's try and set count again. Because, the first 2 times didn't work. During each button click, I would like to increment count by 1 3 times, but we're still only updating by 1 still. Here's the reason why. We're using the current state of count to calculate the next state. After using a setter function, this doesn't trigger an update. React batches together updates for performance reasons. You would imagine that after these functions, we would update. But that's not necessarily the case. Using React, we batch together these state updates for performance reasons. In reality, it's going to look something like this. We're taking count, which is 0, adding 1 to it. Count didn't update yet. It's still 0. Add 1 to it. Take count, which is still 0 because we didn't update. Add 1 to it. In reality, what we're doing is setting count to be 1 3 separate times, and then updating. This would be similar to me hitting the refresh button on my web browser a bunch of times. We've sent a bunch of commands to refresh the web browser, but we may only end up refreshing once, not each time I click the button. That's because our web browser has its own event loop cycle. That's a similar way of thinking about it. If for some reason you need to use multiple state updates, you'll want to use an updater function. Here's how. We're going to write a function. Our function has one parameter, count in this case, arrow, then do this. Let's write an arrow function for each set count. So this will work. However, you'll want to rename count to be something else. We're going to be working with the previous state of count, not the current state. We're using the previous state of count to calculate the next state. According to the React documents, you'll want to rename count as either something like previous count, such as this, or you can take the first letter of the state variable, in this case C. I find taking the first letter of the state variable much more easier to read. It's less verbose. So this will work then. When I press the increment button, we're updating the state 3 separate times. C represents the previous count, not the current count. With our updater function, we're taking the pending state to calculate the next state, not the current state. We don't update until later. When we pass in an updater function, we're adding all of these updater functions to a queue. A queue is a type of data structure. A queue is similar to a bunch of people waiting in line. It's first come, first serve. The first person in line is going to be helped first. So during the next render, it will call all of these functions in order, rather than batch them all together. When using multiple state updates, you'll want to be sure to use updater functions. It is good practice whenever possible to use updater functions, just for consistency. Even if you're only going to update the state once, it would still be good practice to use an updater function. It will help future-proof your code in case you ever need to update the state again. So now let's take our decrement function. Currently, we're updating the current state of count, not the previous state. Let's begin by setting up a parameter of count. Arrow, then do this. But we'll want to be sure to rename count, just to show that we're working with the previous state, not the current state. Let's rename count as the first letter of the state variable, which is C. C, arrow, take C, -1. Let's do this 2 additional times. Now when we increment, we will increment 3 separate times. And we can decrement 3 separate times. Now last we have reset. With the setter function, we're not dependent on the previous state. All we're doing is setting count to be 0. If I was going to use an updater function, it would look like this. C, arrow, C equals 0. We really don't care about the previous state. This would still technically work. We don't really need our count for anything. We're setting C equal to 0. Because by passing in 0, we're already setting it to be 0. In this specific example, an updater function wouldn't be necessary because we don't need the previous state. Alright everybody, so those are updater functions. It's a function passed as an argument to set state, usually. When updating a state variable, you'll pass in an arrow function. If we were working with a state variable of year, I would pass in an arrow function that looked like this. We have a parameter of y, arrow, let's take y plus 1, if I was incrementing our year by 1 in this case. By using updater functions, they allow for safe updates based on the previous state, not the current state. This allows for multiple state updates and is used with asynchronous functions. It's a good practice to use updater functions whenever possible. We will be using updater functions in the future. And well everybody, those are updater functions in React. Hey everybody, so in today's video I'm going to show you how we can update the state of objects. Be sure that you're importing the useState hook from React. So we'll begin by creating a constant, use array destructuring. Our object will be a state variable of car. Then we need a setter variable for this car. Set car equals the use state hook. You can set the initial state with useState. So what we're going to do in this lesson is create a JavaScript object. We're going to create your favorite car with 3 properties: a year, a make, who manufactured the car, and a model. So pick a car that you like. I like a 2024 Ford Mustang. If you would like, although not necessary, you can put each of these properties on a new line for readability. Personally, I find that easier to read. So, car is going to be an object with these 3 properties. But later on, we're going to update these properties with a few text boxes. Within our return statement, we will create a div element to wrap everything. I will create a paragraph with some text. Your favorite car is... So we have that text currently. We'll add our car's year, followed by the car's make, then the car's model. So for me, my paragraph states, your favorite car is a 2024 Ford Mustang. After our paragraph element, we're going to create 3 input elements, one for year, make, and model. So let's do that. I will create an input element. The type of this input element will be number for the year. So we should have some arrows on this input element to increment or decrement. I will set the initial value to equal the year of our car, car.year. I'll add a break afterwards. Let's copy this input element, paste it twice. The second input element is going to have a type of text for a string. The initial value will be the make of our car, in my case, Ford. The third input element will have type text. The value will be model. I have a 2024 Ford Mustang. When I interact with these input elements, I would like to change the property of my object. We'll need to use the onChangeEvent handler. The onChangeEvent handler is going to accept a callback to some functions. Function handle year change. There will be one parameter, an event. The event object is going to be provided to us through the onChangeEvent handler when we add that in a moment. Let's copy this function, we'll fill it in later. Then we will have a function to handle make change. Then handle model change. We have our 3 functions to change the year, the make, and the model properties of our object. With our input elements, we will set the onChangeEvent handler equal to a callback to handle year change. So let's set the onChangeEvent handler to the other 2 input elements. OnChange, handle make change, onChange, handle model change. The last thing we got to do is finish filling in our functions. We'll begin with handle year change. If I want to change the state of my car object, I will use the setter function that's provided to us with useState. set car, set of parentheses. We will be using an updater function, but there's something I want to explain first. We're going to set our car to be a JavaScript object. If I were to take the year and set it equal to 2025, this is what happens if I interact with this input element. Let's say I decrease this input element. Well, the value changes to 2025. That worked, but the make and the model of our car disappeared. These properties no longer exist. What we've ended up doing is replacing the initial object that has these three properties with a new object that has this one property of year. We need some way to retain the make and model of our car, the previous properties that we're not updating. That's why we're going to precede this property to be changed with the spread operator of our car. When we update the state of our car, we're going to be creating a new object, spread all of the current properties of our car, and add a year. After using the spread operator, it's going to look like this. We'll have a year, make, model, and year again. If you have an object with two properties with the same name, you'll end up using the later one and disregarding the first. JavaScript doesn't allow for duplicate keys. That's why we're going to be using the spread operator on our car object, then updating the year. That should allow us to retain the previous properties. If I were to interact with the year, we'll retain the previous properties. They won't change. Currently, this setter is only set to change the year to 2025. We're going to access the event object provided to us from the onChange event handler behind the scenes. I will change the year to be access our event object, access its target, access its value. When I interact with this input element, the year property is going to change accordingly. But a better practice with useState would be to use an updater function, which we learned about in the last video. We don't want to modify the current state of car, but rather make a reference to the previous state. This allows for safe updates. We're going to turn this object to be part of an arrow function. So let's create our arrow function. We will take our car, arrow, do this. So with an arrow function, if you have a set of curly braces after the arrow function, JavaScript thinks you're trying to write a multi-line statement, but that's not the case. We're trying to create a JavaScript object. What you could do is surround your set of curly braces with a set of parentheses. That will allow you to create an object within an arrow function. Since we're working with the previous state of car and not the current state, we would want to name this to something else. One common naming convention is to take the first letter of the state variable and use that to indicate that this is the previous state. So C will be our parameter. We will use the spread operator on the previous state of car, represented as C. And that should work. This allows for safe updates, especially if you're updating the state of your car more than one time within a function. See my video on updater functions if you'd like to learn more about that. Alright, then we have to handle make change. We will use our setter, set car. We're going to be replacing the initial object with a new object. We will use the spread operator on our car, access the make, set it equal to, access our event parameter that's provided to us, access its target, access its value. We'll upgrade the statement so that it's an updater function. Let's take our car, arrow, do this. Then we will rename car as C to indicate that we're working with the previous state of car, not the current state. I can change my year, and I can change the make. And that should update. We have one last function to work with. Handle model change. Again, set car. We're creating a JavaScript object. Use the spread operator on our car to spread the properties so we don't lose them. Update the model with our access our event, access its target, access its value. Then we'll change this to be an updater function. We have parameter of car, arrow, do this. Since we're creating a JavaScript object within an arrow function, we need to surround it with a set of parentheses. And then rename car as C to indicate we're working with the previous state. And that should work. I will change the year, the make, and the model. Alright everybody, so that is how we can update the state of an object using React. Hey, what's going on everybody? In today's video, I'm going to show you how we can update the state of an array using React. Alright everybody, here's how we can update the state of an array using React. Be sure to import the useState hook from React. We'll begin by creating a constant, use array destructuring. The name of our array will be foods, because I'm hungry, like usual. We'll need a setter function for the state variable, set foods, equals use state. We will set the initial state to be an empty array. If you would like to include some initial elements, you can put that within here, such as an apple, an orange, and a banana. We'll create two functions, a function to add an element to this array, and another function to remove an element. We'll create a function to handle add food. There are no parameters. And we'll declare a function to handle remove food. We'll fill these in later. Within our return statement, let's wrap everything within a div element. I will create an h2 heading that says list of food. We'll create an unordered list with a pair of UL tags. Within my unordered list, we will embed some JavaScript code. Let's take our array of foods, use the built-in map method. The map method will return a new array. What would we like to do with all of these elements of our array? Well, we're provided with an element, which we will name as food, and an index. These are the parameters that we'll receive automatically. We'll write an arrow function to do something. I will create a list item element. We have 3 already, because our array initially has 3 elements, an apple, orange, and a banana. If I were to go to my console, React wants us to add a key for each list item so it can keep track of them. So with the opening list item tag, I will set the key attribute to equal our index. Within each list item, I will add the current food element. And let's see if this works. Yes, it does. Apple, orange, banana. If I were to change the initial values of this array within useState, that should be reflected. After the unordered list, we'll create an input element to enter in the names of some food. I will create an input element. The type will be text because we're adding a string. I will set the ID equal to be food input. I'll add a placeholder too. I will set the placeholder attribute to be enter food name. After this input element, let's create a button. The button will have text of add food. With this button, I will set the onClick event handler equal to a callback to handle add food. Let's work on the handle add food function. We need to get the value found within this input element. If I were to type coconut, then press the button, I need to get this value. But first we'll select this input element to access it. I will create a constant of new food. New food will be a string. It's going to contain this value. I will access this element, this input element, document.getElement by ID. The ID that I'm getting is food input. I would just like the value, not the entire element. So if I were to type in coconut, press the button, new food is going to be a string of coconut. Then after pressing the button, I'm going to reset this input element so it clears like this. I can do that by copying this line of code where we access the value, set it equal to be an empty string. So if I were to type in something, it should reset after hitting the button, which it does. Let's try a mango. And that resets too. So we have the string that contains our new food. We'll use our setter to update our array. If I were to pass in a new array, then add new food, this is what happens. I will attempt to add a coconut. Add food. Our initial values of apple, orange, and banana, they're all gone. We've replaced the initial array with a new one that contains only one string element. our new food that we're trying to add, we need to copy over the previous elements of this initial state. Within this new array, when setting the state, we will use the spread operator and access our array of foods. The spread operator, when used on an array, will spread all of these elements into separate values. It'll look something like this. We're replacing the initial state of this array with a new one, so we need to copy the old elements over. So this does work. I will attempt to add a coconut and a mango. However, it would be best practice if we were to use an updater function. We don't want to directly work with the current state of a state variable, rather the previous state. I will upgrade the statement into an updater function. We will take foods, arrow, do this. You don't want to use the same name as the current state variable. A common naming convention is to take the first letter of your state variable and use that as a parameter. Foods will become F for the previous state. We will use the spread operator on the previous state of foods. And that should work. We have an apple, orange, banana. We can add a coconut or a mango. Now we're going to complete the handle remove food function. There's one or two things I need to change. Make sure we use camel case naming convention. I accidentally made the R lowercase. There's going to be one parameter, an index number, because we'll be working with the index numbers of these list item elements. Within our unordered list, we'll be working with the opening list item tag. Just for readability, I'm going to put this on a new line. Like so. Within the opening list item tag, we will set the onClick event handler equal to a callback to the handle remove food function. This function needs a parameter. In order for us to pass in a parameter to the handle remove food callback, we need to convert this to an arrow function. We'll create an arrow with no parameters, arrow, do this. Within the map method, we're provided with an index number. We'll be passing in that index number to this function so we can work with it. Within the handle remove food function, we will use the setter for our foods. Within the setter, we'll use the filter method. We will take our foods, use the built-in filter method of arrays. With the filter method of an array, we are provided with an element and an index number for that element. However, we do have a naming conflict. We've already stated that the parameter of this function is going to be index. Just to differentiate it, I'm going to rename index as I. So within the filter function, we will use an arrow function to do something. We're going to filter all elements where the current index, represented as I, does not equal the index that we receive. So if you take a look, our element parameter is provided to us, but we're not using it. You can see that it's kind of grayed out. We're going to replace this with an underscore. Using an underscore for a parameter is a convention to indicate that the parameter being passed to the function is ignored. So with parameters, if you see an underscore, that means ignore it. All right, and this should work. I will add a coconut, a mango, then I can click on one of these list items to remove it. Let's remove our banana, our apple, and the mango. All right, everybody, so that is how we can update the state of arrays using React. Hey everybody, in today's video I'm going to show you how we can update the state of an array of objects. If you're able to comprehend this lesson and you've watched previous topics, we'll be ready to make a few projects in React. So let's get started. Like we've done in prior lessons, be sure to import the useState hook. In this topic, we're not going to create one state variable, but four. Const cars. Cars is going to be an array of objects. Then we need a setter for our array of cars. Equals use state. I'm going to set the initial state to be an empty array. Then we will create a state variable for the car's year and a setter for car year. Use state. If we're going to be adding car objects, to make it easier for me, I could set the initial state to be a year like 2024. something that's kind of recent. But I think it would be a lot cooler if we use JavaScript to get the current year. Right now I'm filming this video in December 2023. For the initial state, I'm going to create a new date object, then get the full year method. For me, this is going to return 2023, but depending on when you're watching this video, it might be later. We'll create a state variable for our car's make. Who manufactured the car? Set car make equals use state. I will set the initial state to be an empty string. Then we need the model. I'll just copy this because I'm lazy. Change make to be model. Set car model. The initial state for the model will be a string. All right, now we're going to declare all the functions we'll need throughout this application. We'll create a function to add a car, remove a car, change the year, change the make, change the model. 5 functions total. We'll declare a function to handle add car. Then a function to handle remove car. There is one parameter, an index. What is the index of the object that we're removing from this array? We need a handler for year, make, and model. Function handle year change. There is one parameter, an event. That will be provided to us through the onChange event handler. We need a function to handle make change, handle make change, and handle model change. So we should have 5 functions total. Add car, remove car, change the year, change the make, change the model. Let's create our HTML elements. So within our return statement, I will create a div to enclose everything. Let's create an h2 element for a heading. List of car objects. Afterwards, I will create an unordered list. We will populate this unordered list later. We will create 3 input elements for the year, the make, and the model of our car that we're trying to add. We will begin with input that has a type of number. I will set the value to equal the state of car year. And for me, that's 2023. That's because I'm creating a date object of the current date and time, then returning the year. Depending on what year you're watching this, it might be different. I will set the onChange event handler equal to a callback to handle year change. I'll add a break afterwards. Okay, let's copy this input element, including the break. The type of the second input element will be text. The value will be the car's make. Who made the car? The onChange event handler will be a callback to handle make change. We should add a placeholder to tell the user what we want them to type in. It's not very apparent. I'll put this on a new line for readability. I will set the placeholder attribute equal to enter car make. Let's copy this element, paste it. For the third input element, the value will be car model. The onChange event handler will be a callback to handle model change. The placeholder will be enter car model. Then we'll create a button to submit our car object. Button. The text on the button will be add car. We will set the onClick event handler equal to handle add car. All right, now we have to fill in these functions. We'll begin with handle year change because it's easy. We will use the setter for set car year. We will pass in access our event object that's provided to us, access its target, access its value. Then we have to do this with make and model. Set car make, access the value of the target of the event. Pass it as an argument. set car model. Again, take our event, access its target, access its value. So now we should be able to update these values. Let's try it. When I click on the button, I would like to add this object to my array of objects. Within our handle add car function, we have a few things to write. It's not as complicated as what you think it might be. Using these state variables of year, make, and model, we will create a new car. Const new car equals a JavaScript object with these properties. The year will equal the current state of car year. The make will equal the current state of car make. The model will equal the current state of car model. Then, just for readability, I'm going to put all of these properties on a new line. Not necessary, but I find it easier to read. We will use the setter for our array of car objects. We will use an updater function. We will take cars, arrow, create a new array, use the spread operator on cars. We need to copy the previous elements over to the new array. We don't want to lose them. Then we will add a new element, our new car object. So we don't want to use the current state of cars, but rather the previous state with this updater function. A common naming convention for your parameter is to use the first letter of that state variable. Let's rename cars as C. So what we're going to do now is go to our unordered list. We need to populate it with list items. I will embed some JavaScript, take our array of cars, use the built-in map method to return a new array. We're provided with two arguments, an element and an index with the map method. But I'm going to rename element as car, so it's more understandable. What would we like to do? I'll use an arrow function. We will return a list item element. And for readability, I'm just going to place these on a new line. React wants us to add a key to each list item element, so let's take care of that. I will set the key of each list item element to be our index that's provided to us. Within each list item element, I will display the car's year, followed by the car's make and the car's model. All right, let's see if this works. Let's add a 2023 Ford Mustang, and that worked. How about a 2024 Chevrolet Corvette and a 2022 Dodge Challenger? One thing I'm going to add to the handle add car function, after submitting a car, I would like to reset these values. At the end of this function, let's use the setters. I will set the car year when we're done with it to be the current year. We'll create a new date object, get the full year, update the state to whatever value is returned. We'll use the setter for the car make and reset it to be an empty string. Same thing with the car model. All right, let's see if this resets. 2023 Ford Mustang, and it does. 2025 Chevrolet Camaro, and that does reset. You can see that my year went back to 2023, even though I adjusted it to 2025. The make and model were both replaced with empty strings. Now I would like to remove a car when I click on one of these list item elements. We'll make one change to the opening list item tag. I will set the onClick event handler to a callback to handle remove car. We do have to pass in an argument, though, to this function. We have to pass in an index. What is the index of the car we're trying to remove? If I attempt to pass in an argument, we will call this function right away. We will convert this callback to an arrow function that has no parameters. So within the handle remove car function, there's not a lot to write. We will use the setter for our cars. We'll use an updater function. We don't want to use cars, but we'll use the first letter to indicate we're working with the previous state. Arrow, take the previous state of our array of cars, represented as C, use the built-in filter method. We will filter any cars that don't meet a certain criteria. The filter method provides us with an element and an index, but we do have a naming conflict. We already have a parameter with the name of index. Let's rename the index of each element within our array as I. Then do this with an arrow function. We'll write our condition. Check to see if the index of the current element, I, is not strictly equal to the index we would like to remove. We'll filter out that element when we create a new array. So we're not working with the current element, even though it's provided to us. So what people do as a convention, if you have a parameter you're not using, people will change the name of that parameter to be an underscore. That tells other people to ignore this parameter. And that should work. Let's run and test everything. Let's add a 2023 Ford Mustang, but feel free to pick some different cars. 2024 Chevrolet Corvette. 2022 Dodge Challenger. And I should be able to remove a car when I click on it, that list item element. Our Corvette is gone, our Mustang, and our Challenger. Alright everybody, so that is how to create an array of objects and update their state using React. Hey everybody, in today's video I'm going to walk you through creating a to-do list app using React. So sit back, relax, and enjoy the show. Alright, let's do this everybody. We'll need to create a new JSX file. Going to our source folder, we will right-click, new file. This component will be named to-do-list.jsx. This will be a function-based component. Function, to-do-list, no parameters. Then let's be sure to export it, because if I don't do it now, I'm going to forget. Export default to-do-list. We will be using the useState hook. We should import that. Import React, use object destructuring. I would like just the useState hook from its location of React. We do need to return something. For now, we're just going to return a fragment. Going back to our app component, we need to import our to-do list component. Import to-do list from its relative file path, /to-do-list.jsx. We will return one to-do list component. And we are ready to move on. Within our to-do list component, we will have two state variables. Const tasks. Tasks will be an array of strings. We need a setter function for tasks. Set tasks equals the useState hook. The initial state of tasks is going to be an empty array, but eventually we're going to populate this array with strings, one string for each task to add. And we will create a state variable for a new task. New task is whatever we're currently editing with a text box. We will be adding our new task to our array of tasks. Then we need a setter function for new task. Set new task equals useState. The initial state will be an empty string. Let's declare the functions we'll need throughout this program. We will need a function to handle input change. There will be one parameter, an event. This function is for our text box when we type in something. We'll need a function to add a task. Function add task. There will be no parameters. Function delete task. There will be one parameter, an index. An index of the list item we would like to delete. Let me scroll down. A function to move task up. There is one parameter, an index. What is the index of the list item we would like to move up within our list? And a function to move task down. We will also accept an index. Okay, and these are the functions we'll need. Until we fill these in, I'm going to close these functions. Okay, now we'll go to our return statement. we have a lot of HTML elements to add. We'll begin with a div element. Our div element will have a class name of toDoList. Within this div element, we'll create an h1 element for a heading. The heading will be toDoList. After this h1 element, I'll create another div element. Within this div element, I will create an input element. This will be a self-closing tag. Just for readability, I'm going to place each attribute on a new line. We have a lot of attributes to write. I will set the type of this input element to be text. I'm going to zoom in so you can see it more easily. I'll add a placeholder of enter a task, ... Enter a task. I will set the value of this text box to be some JavaScript, our new task state variable, this one. When we type within this input element, we will use the onChange event handler equal to a callback to a JavaScript function, a callback to handle input change. We'll fill in this function since we're here. Going to handle input change, we will use the setter for our new task. Access our event parameter, access its target, access its value. So when we type within the text box, it should change. Eat breakfast. If we didn't set the new task, and we type within the text box, we don't see the text. It doesn't change. That's why we need this function. So we can see the text when we write within the input element. Let's scroll back down to the bottom. After our input element, we will create a button element with text of add to add a task. For the class name of the button, we'll set the class name attribute of the button to be add_button. I will set the onClick event handler equal to a JavaScript callback. We will call the function of addTask. Now, temporarily, until we apply some CSS, I'll write a few tasks within our array. Just temporarily. Let's say our first task is to eat breakfast, take a shower, and walk the dog. After our div element, we'll create an ordered list with a pair of OL tags. Within this pair of OL tags, we'll be embedding some JavaScript. We have a lot to write. We're going to take all of our tasks and use the map method. We will create a list item element for each task, for each element within this array. We'll use the map method. We're provided with two parameters, the current element and the index of the current element, but I'll rename this element parameter as task, so it's more easily understandable. Within the map method, we will use an arrow function. What would we like to do with each task? I'll put this on a new line. We will create a list item element. So currently we have 3 list item elements. Now React wants us to add a key for each element, so it can more easily keep track of each element. With the opening list item tag, I will set the key attribute equal to the current index. Within the list item element, I will create a span element for some text. The class name for this span element will be text. This will be for the text of each list item element. Within the span element, we will include the current task. We have 3 tasks: eat breakfast, take a shower, walk the dog. After our span element, we'll create a button element. This button element will be for a delete button, to delete this task. This button will have a class name of delete-button. I will set the onClick event handler equal to a callback to delete task. Now we do have to pass in a parameter, the index of the list item we would like to delete. Delete task pass in the current index. With a callback, if you add a set of parentheses right away, when we pass in an argument, this will call the function right away. Instead, we will use an arrow function to prevent that. Let's copy this button, paste it. We'll now create a move up button to move a task up if we need to change the priority. The text on the button will be up. But you know what? I like to use emojis. I'll use a pointer finger. I think that would be more fun. The class name will be move button. On click will be set equal to a callback to move task up. We'll be passing in the current index. Make sure that this is an arrow function too. Let's copy this button again, paste it. This next button will be for move task down. We can either write down for the text, or I'll use an emoji for fun. Down. Alright, and that is all the HTML that we need. Before we fill in these functions, let's apply some CSS to everything. I'm zoomed in to 100% currently. Let's select the container of to-do list, this div element. So this has a class of to-do list. Let's change the font family to be Arial with a backup of sans serif. Text align center, decenter the text, and add a little bit of margin to the top of 100 pixels. Let's select our H1 element, increase the font size to 4 rem. Then we'll select all buttons. Increase the font size to 1.7 rem. Set the font weight to be bold. Add some padding around each button. Padding 10 pixels by 20 pixels. Set the font color to be white. We'll add some background color pretty soon. Remove the border, border none. Border radius to smooth the corners by 5 pixels. Change our cursor to be a pointer when we hover over a button. That does appear to work. We'll add a transition effect when we hover over a button. Let's change the background color and have it ease after 0.5 seconds. Let's work on the background color of the buttons next. We'll select the class of add button. Add dash button. Pick a background color. I'll pick green, but I will use HSL values. I've already pre-picked a color. Now, when I hover my cursor over the add button, access the hover pseudo class, take the lightness, make it 10% darker. Let's do this with the delete button. Let's copy what we have, paste it. For the next set, change add to delete. I'll pick a red color. Again, I've already picked some values. And when I hover, make the shade 10% darker. And the move buttons. I'll make the move buttons blue. Again, I've already picked a color. Not bad. It looks like with the transition, I forgot to add S for seconds. That's better. We'll work on the input element next. So after our buttons, let's select our input element. We'll select all input elements that have a type attribute of text. I'll increase the font size to 1.6 rem. Add a little bit of padding, 10 pixels. Add a border, 2 pixels solid. Pick a color. I'll set the lightness to be 80%. but lower the alpha to 50%. Not bad. Border radius to smooth the corners, 5 pixels. And for the font color, let's find something. I'll just lower the alpha to 50%. Here's the text currently. I'm happy with that. We'll work on the list items. We'll begin with our ordered list. Remove all padding. Padding 0. So that should delete the numbers. We will style each list item element. Increase the font size to 2 rem. Set the font weight to be bold. Add some padding of 15 pixels. Change the background color. I'll set the lightness to 97%. Add some margin to the bottom of each list item of 10 pixels to separate each of them. Add a border. 3 pixels solid. Pick a color. For the lightness, I'll pick 85%. And the alpha down to 75%. Border radius around the corners, 5 pixels. For the elements within each list item, I'll use Flexbox. Display flex to align everything. And align items center. I would like the text to take up as much space as possible. So I will select the class of text, use Flexbox, set it to 1. Flex 1, it's a shortcut for these 3 CSS properties. Flex grow, flex shrink, and flex basis. This is more advanced Flexbox. If you set an element to have flex 1, you're applying these 3 properties. Basically speaking, that element should take up as much space as possible and grow and shrink with the size of the web browser. So all these buttons are going to be pushed to the right because the text wants to take up as much space as possible. Okay, now we will select the class of our delete button and move button. These 2 sets of buttons. Let's add some padding. 8 pixels by 12 pixels. Increase the font size to 1.4 rem. I'll add some margin to the left of each button. Margin left 10 pixels. Much better. This is optional, but I'm going to change the background color of the body of my document. I will select the body, change the background color. I'll go with the dark gray color. I'll set the lightness to 10%. I'll also take our H1 element and set the font color to be white. I think that looks pretty good, but you don't necessarily need to change the background color if you don't want to. Our CSS is now done. We just have to add some functionality. Let's go back to our to-do list component. We'll begin with add task. After hitting the add button, we'll call this function to add a new task. We have to get the text within this text box. We'll use the setter for set tasks. Pass in a new array. Spread the current elements of tasks. And add our new task, that state variable. We should update this to use an updater function. We will use the previous state of tasks, represented as t. Arrow, spread the previous state of tasks, represented as t. We would like to clear this input element, so we can set new task, set it to be an empty string to reset it. Now we should be able to add a new task. Go to work and add. And that has worked. Eat lunch. Now, if somebody doesn't type in anything, they can still add a task. To prevent that, with an add task, we'll wrap everything within an if statement. Take our new task. Use the trim method to remove any white space. If, after removing any white space, if this is still strictly not equal to an empty string, then add a new task. So now, when I try and add an empty task, it doesn't do anything. Let's add some text. Go to work. And that will work. The add task function is now done. Let's work on delete task. Delete task provides us with an index of the element we would like to delete. Maybe I don't want to take a shower. I'm only a little bit stinky. So within delete task, we will create a new array of updated tasks. So we need to use the filter method. Take our array of tasks, use the filter method. With the filter method, we're provided with an element and each index of that element during each iteration. But we have a naming conflict. We already have a parameter named index for the index we would like to delete. We'll rename index within the filter method as I to differentiate it. Arrow, then a condition. If the current index of I is strictly not equal to the index we would like to delete, put it within our new array of updated tasks. If these two indexes match, we will filter it out. We don't want it, because we want to delete it. Then, once we have our new array of updated tasks, it should be missing that element. Now, we're currently not using this element parameter, even though it's provided to us. A common convention that people do, if a parameter should be ignored, people will change this to an underscore. That's a convention to say, ignore this. We will set our new tasks with our updated tasks. And this is an array that's missing one element, whichever one we filter out using the filter method. Now we should be able to delete an element. I do not want to take a shower. Delete. And I don't feel like going to work. Delete. Delete task is now done. Now we need to be able to move a task up or down using the directional buttons. So let's work on task up. First, let's check to see if our index that's passed in as an argument is greater than 0. If the element is already at the top, we don't need to move it up further. We need to create a new array of updated tasks equals spread the current tasks and create a new array of updated tasks to work with. Now, we're going to use array destructuring to swap two elements within an array. Here's the formula. We have the current index and the index minus 1. We will be swapping these with index minus 1 and the current index. So take our updated tasks at the current index and the updated tasks at index minus 1, set these equal to updated tasks at index minus 1 and updated tasks at the current index. I do have a separate video on destructuring if you need a refresher. This code will swap two elements within an array. And then we will set our tasks using the setter function. Set tasks, pass in our updated array. And now we should be able to move an element up. Oops, looks like we have two functions for move task up. Move task down. All right, let's see if this works. And now we should be able to move these up. With move task down, we're going to copy everything within move task up. The condition is if our index is less than our task's length property minus 1. If our element is already at the bottom, we don't want to move down any further. Take index plus 1 and then update our tasks. Now we should be able to move tasks up and down and even add new tasks. And delete tasks. And of course, to initially have no elements within this array, we can delete all these. So then we start with an empty array. All right, everybody, so that is a somewhat extensive program to create a to-do list application using React. Hey everybody, we have an important topic to discuss today, and that is the useEffect React hook. useEffect is a React hook. Basically speaking, useEffect tells React to do some code when, then pick one of the following. Do some code when this component re-renders, or do this code when the component mounts. When you mount a component, that's when you create and append it to the DOM. That is known as mounting. Or do some code when the state of a value changes. Think of an effect as some side code you would like to perform. I don't really think useEffect is a great name. If I could rename useEffect, I feel like a more appropriate name would be useSideCode. But that's just my opinion. So think of an effect as some side code. You'll write your side code within a function. This can be a callback, an anonymous function, or an arrow function. And optionally, for the second argument, you can pass in an array of dependencies. If we would like to run our side effect on every re-render of the component, we would just need to pass in a function, such as an arrow function. Do this code every time the component re-renders. If you would like to perform some side code only when the component mounts, and not during every re-render, you would pass in an empty array of dependencies. That tells React, perform this code only once when the component mounts. Within your array of dependencies, if you were to pass in a value, this code would run when the component mounts, plus when this value changes. useEffect has a bunch of different uses. You'll see useEffect with event listeners, DOM manipulation, subscriptions to real-time updates, fetching data from an API, and cleanup when a component unmounts. Unmounting is when you remove a component from the DOM, whereas unmounting is adding a component to the DOM. Okay, let me give you a few examples. In order for us to use useEffect, we have to import it from the React library. We have useState as well as useEffect. In this example, we're going to create a count state variable. Const count and a setter for count. Set count equals useState. The initial state of count will be 0. And we'll display our count within our return statement. Let's create one paragraph element that has text of count, as well as our state variable of count, and a button. Let's create a button element that has text of add. When we click on add, we will add 1 to our count. We'll need a function to work with. I will set the onClick event handler equal to a JavaScript function. Let's name this function addCount. Then we just need to declare this function. Function addCount. All we'll do is use our setter for count, take the previous state of count as a parameter, arrow, do this. Take the previous state of count, add 1. Every time I press the button, we will add 1 to count. Now let's use useEffect. I can run some side code every time this component re-renders. I would just have to place that code within a function that will pass to useEffect. Every time this component re-renders, I will change the title of the document. We'll need to use useEffect. Be sure to place useEffect near the top of your component. We will call useEffect. There are 2 arguments, a function and an array of dependencies. I would like to perform some code every time the component re-renders. I do not need that second argument. Now we just need a function. This can be a callback, an anonymous function, or an arrow function. We're going to be using an arrow function. Every time this component re-renders, what would we like to do? Let's access our document, access the title, set it equal to be a template string of count, and insert our state variable of count. Let me refresh. Every time this component re-renders, including initially when we mount the component, we will perform this code, where we update the title. Every time I press the add button, the title is going to update. If you would like your side code to run only when the component mounts, when we create and add it to the DOM initially, you'll pass in as a second argument an empty array of dependencies. So if I were to run this again and press add, well, our title only updates once, and no other time after that. For example, I might want to set my title to be my counter program. I only need to update this title once. I don't need to update it every time the component re-renders. It's a one and done effect. In this case, I would like to add an empty array of dependencies, because if I didn't, Well, we would update this title every time the component re-renders, when we really don't need to. In this specific example, it doesn't benefit us to update the title every time we add 1 to count. Let's revert those changes back. You could pass in a value to your array of dependencies. Within your array of dependencies, you can add a value. Let's add our count state variable. What we're telling React is that when our component mounts, plus when this value changes of count, then do the side code. So with what I've written currently, every time I press the button, the title is going to update. If our count state variable updates, perform our side code. This is very similar to us not having that dependency array. You know, this will work too. However, since we don't have any dependencies, this code is going to run for any reason that this component re-renders, even for something completely unrelated. By adding an array of dependencies and placing a value within, do this code only when this value updates. Now to demonstrate, we'll create another button to subtract. The text will be subtract. We'll create a function to subtract count. We can copy this function, paste it, change the name to subtract count, take the previous state of count, -1. So if our count changes, whether we add 1 or -1, the title of our document is still going to change. If the value of count changes for any reason, do the side code. Let's add another value to our dependency array. We will create a state variable for color. Color and set color equals use state. The initial state for my color will be green. We'll flip between green and red. Green means go, red means stop. After our subtract button, I will add a break and a button to change the color. Change color. The onClick event handler will equal this function of change color. And we just need to define this function. Function change color. We will use the setter for set color. We will use the previous state of color. Is the previous state of color strictly equal to green? Ternary operator. Is this true? If it is, return red. Otherwise, return green. Then we will take our paragraph of count, access the style attribute, set it equal to, embed some JavaScript. We need a JavaScript object, so we need another set of curly braces. Take the color property, set it equal to our color state variable. So now the count is green. With our title, let's also add the color. So I'm not going to add our color to our dependency array quite yet. We can add, the title updates, we can subtract, the title still updates, but if we change the color changes of this paragraph element, but not the title. We're executing this code only when the count changes. So even though I'm flipping between red and green, the title is still staying the same. If I were to add our color to our dependency array, anytime the count or the color changes, update the title. So let's try this again. The title updates when I add, or subtract, or change the color. Now the title is count 1 red, count 1 green, count 1 red, count 1 green. So that's where your dependency array comes in. Anytime one of these values change, perform this side code. Now you may have noticed if you remove useEffect, well, your title is still going to update. So why would you need useEffect? There are a couple benefits of using useEffect. The first benefit is that by using useEffect, it keeps your code more organized. If you were to look over some React code and look within the useEffect hook, you could tell when exactly this code runs. Does it run during every re-render, only when the component mounts, or when one of these values change? If you didn't use effect, well then this code would run every single time regardless, every time the component re-renders, which you may not always want. But not only that, but with more advanced features such as event listeners or subscriptions, you may want to remove or free up those resources. You can return a cleanup function. If you were to return a function, when this component unmounts, when we remove it from the DOM, or before the next render, you can perform some cleanup code. For example, if we were to add an event listener when the component mounts, we would like to remove it before unmounting. If we don't, it may lead to unexpected behavior. So that's another benefit of using useEffect. Perform some code only in certain situations, and you do have the option to do some cleanup code before the next re-render or when you unmount the component. I'll discuss the return statement in this next demonstration and how it can be useful. In this next example, we're going to create a width and a height, what the width and the height of our window is. Every time we adjust the size of the window, the width and the height displayed is going to change. We'll need two state variables to work with. A width, set width. We will be using useState. So the initial state of the width of the window, access our window, give me the inner width property. Then let's do this with height. Const height, set height, window dot inner height. Within our return statement, we will create a paragraph element that has text of window width. We will display our width state variable, then add pixels for a unit of measurement. Then let's do this with height. Window height. Display our height state variable. So we have window width and window height. If I were to adjust this window, nothing happens. There's no change. Let's create a function to handle resize. Function handle resize. No parameters. We're going to set our width to be the inner width property of our window. And set height, H should be capital. Set height, take our inner height of our window and reset it. So now we need to add an event listener because this still doesn't change. We're going to add an event listener that will listen for a resize event whenever we resize our window. If we attempt to use this without useEffect, but within the body of our component, we will take our window, add an event listener. We need an event and a function to do something. The event is going to be a resize event. When the window is resized, perform this code. We will pass in a callback to handle resize. And then, for demonstration purposes, I'm going to console.log event listener added. We only need one event listener to make this program work. Now, if I were to resize my window, this does work. Our width state variable changes. Same thing goes with the height. Now let's take a look at our console. There's an issue. We only need one event listener to make this program work. However, every time the component re-renders, we're adding a new event listener. We have added over 1,000 event listeners. That's really not good. How about this? Only when our component mounts, when we append it to the DOM, we will add one event listener, and that's it. So guess what? We're going to place our code within useEffect. We will pass in a function and an array of dependencies. When would we like to add an event listener? Let's add an event listener only when the component mounts. So we need to add an empty array of dependencies. Let's try that again. I'm going to resize our window. That should be good. Go to inspect. Yeah, you can ignore all this garbage. So if you have strict mode on, which I do, useEffect is going to run twice. it will run a development only setup and then a cleanup cycle. So this is normal. So we didn't add thousands of event listeners. Besides the first cleanup cycle, because I have strict mode on, we're only adding one event listener, because that's all we need. We don't need thousands of event listeners. If you ever need to unmount the component, meaning remove it from the DOM, useEffect has another use, and that is adding a return statement. To do any cleanup, you will return a function. Do this code either before the next re-render or when the component unmounts. If we add an event listener, then we unmount the component, it would be good practice to remove that same event listener. If you don't, that can lead to unexpected behavior. When we unmount our component, we will take our window, then remove event listener. We will remove the event of resize and a callback to handle resize. When we are done with this component, free up any resources so that it doesn't lead to unexpected behavior. Let me add one more line of code too. Let's console.log event listener removed. Let's refresh, resize our window a few times. Go to inspect, console. Okay, let's take a look. Since I am in strict mode, we'll run our useEffect once during the development cycle and then clean it up right away. Then we will add that event listener only once. We didn't unmount this component yet, so we didn't remove it. So by adding a return statement, you can do any cleanup, either before the next re-render or when you unmount the component. Within a component, you can add more than one useEffect hook. We're going to add a second useEffect hook. If the width or the height changes, we're going to update the title of our document to display the width and the height. So let's add another useEffect hook. useEffect. What code would we like to perform? Let's access our document, take the title, set it equal to B. Let's use a template string. Let's say size, placeholder, width, x, height. When would we like to use this effect? Let's use this effect when the width and the height update. We will need that dependency array. We will list the width and the height state variables. So on mount, we'll get the size right away. 227 by 396. Now, every time the width and the height changes, the title is going to update. So you can have more than one useEffect hook within your component. All right, everybody, so that is the useEffect hook. It's a React hook that tells React to do this code when either the component re-renders, this component mounts, or the state of a value changes. There are two arguments: a function that contains the code you would like to perform, and optionally, an array of dependencies. Based on what you pass into useEffect, you'll either run this code after every re-render, run only when the component mounts, or run when the component initially mounts, plus when the value changes. useEffect is great with event listeners, DOM manipulation, subscriptions to real-time updates, fetching data from an API, or cleanup when a component unmounts. We will have more practice with useEffect in the next video, where we will create a digital clock. And well, everybody, that is an introduction to useEffect in React. Hey everybody, in today's video I'm going to show you how we can create a digital clock using React. So sit back, relax, and enjoy the show. Okay, let's get started everybody. If you would like a background image for your app, place that image within your assets folder. Here's the image that I'm going to use. I found it online. We will create a digital clock component within our source folder. Digital clock.jsx. We will need to import two hooks. Import from React, use object destructuring to get the use state hook, as well as the use effect hook from its location of React. we're going to create a function-based component of digital clock. No parameters. Then be sure to export it at the end. Export default digital clock. We do need to return something. For the time being, we are going to return a fragment, just so that everything runs. Back within our app component, we need to import our digital clock component from its location, /digitalclock.jsx. We will include one digital clock component. Within our digital clock component, we'll create the following HTML. We will create a div element to contain everything. This outer div element is going to have a class name of clock container. Within this div element, we will create a nested div element. This div element will have a class name of clock. We have a clock within a clock container. Within this inner div element, we will create a span element to display a time. Until we get the time working, let's display a bunch of zeros for the hours, minutes, and seconds. And here's our time, but it's a little small. I'm zoomed in currently. Okay, let's go to our CSS style sheet. We will select the following: the body of our document, our clock container class, and our class of clock. If you would like to add a background image, here's what you can do. Within the body of your document, we will set the background image property to be, we will use the URL function. Within this function, we will pass in a relative or absolute file path to your image from the index file. We'll have to access the assets folder. Assets, the name of the image. My image is named background, and this is a JPEG. Okay, here's my image. But it's a little big. Then we will take our background position property, set it to be center, to center the image. Now it does repeat. We'll set the background repeat property to be no repeat. We'll set the background size to cover this div element, the outer div element. Background size cover. Now we'll take the background attachment property, set it to be fixed. As we adjust the size of the window, the image is going to adjust accordingly and maintain its aspect ratio. We do have a little bit of margin around the body of our document. I'm going to remove that. Margin 0. Next, we have to work on the clock itself. It's a little small. Within the clock class, I will set a color of white. I'll increase the font size, because we can barely see it, to 6 rem. That should be a decent size. And a font weight of bold. Pick a font family. I will pick monospace. I think that'll look good for a clock. I will also add a text shadow effect with a horizontal and vertical offset of 3 pixels each, and a blur of 5 pixels. Pick a color. I'll pick black, but I'll lower the alpha to 75% or so. Then I will center align my text. Text, align, center. Our clock is centered horizontally, but not vertically within the window. If you would like the clock in the exact middle of the window, here are some following optional CSS properties you can add. These are optional. We'll use Flexbox. Display Flex to display all the elements. Justify, content, center. To center this clock vertically within the middle of our window, we have to set the maximum height of the body to be 100% of the viewport height. we'll add this following property. Set the minimum height of the body to be 100 VH for the viewport height. 100% of the viewport height. Then, use the align items property, set it to be center, to vertically align it. And I think that looks pretty good. Now we'll select our clock container. For the background of the clock container, I would like it so it looks like we're looking through glass. Here's how to do that. We will use the backdrop filter property, use a function of blur, pass in a number in an amount of pixels. The greater the number, the greater the blur. Here's 5 pixels. Here's 50. What's 500 look like? Okay, let's go with 5 pixels. We have a little bit of a blur effect. If you would like the clock container to take up 100% of the viewport width, you can add the following property. Set the width of the clock container to be 100 VW for viewport width. So now the clock container takes up 100% of the width of the window. Then I'll add a little bit of padding to the top and bottom, but not the sides. Padding, 10 pixels for the top and bottom, 0 for the sides. We should get a little bit of padding on the top and bottom. I like that. I think that looks pretty good. Okay, we can save everything. We no longer need our CSS style sheet. And now we will be working within the digital clock component. We'll be using the useState hook. We will create a state variable of time, const time, and a setter for time named setTime equals the useState hook. For the initial state of the useState hook, we will pass in a new date object. Whatever the current date and time currently is, that's what the initial state of time is going to be. It will be an object. We will also use the useEffect hook. We can perform some code during each render, or when we mount, or anytime some sort of value updates. When this component mounts, we'll start an interval to move the clock forward. There's 2 parameters within useEffect, a function to do something, and an array of dependencies. For our function, we'll use an arrow function. Parameters, arrow, do this. And for our dependencies, based on the last video, we're just going to set an empty array. I would like to start a timer only when we mount the component. We don't need to start a new timer every time the component renders. What would we like to do once when our component mounts? We will create a constant of interval ID equals set interval. With set interval, we can pass in a callback and a time in milliseconds to repeat this callback. Let's do some code every 1000 milliseconds, meaning every 1 second. Let's do the following. We'll write an arrow function to do this. Every 1000 milliseconds, we will update the state of time using our setter of setTime. We will pass in a new date object. And that's all we need. So after every second, we will update the state of time with the new current date and time. Now, if we do unmount this component, it would be good practice if we were to clear our timer. If we don't, it may lead to unexpected behavior. We will add a cleanup function. When this component unmounts, we will return the following. Do this function. We will call the function to clear interval and pass in that interval ID to stop this interval. If we ever unmount our digital clock, we don't want it to continue running. We want to free up any resources. If we don't, that may lead to unexpected behavior. So that is all we need with useEffect. When we mount, and that's it, create an interval that updates once every second. When we unmount the component, clear that interval, and that's it. Now, we will also need a function to format time. Function format time. There are no parameters. We need to get the hours, minutes, and seconds of our time, the state variable of time. That's pretty simple, though. We will declare using let hours equals our time state variable. use the method of getHours. Let's do this with minutes. Let minutes, actually let's declare this as const. Const minutes time.get minutes and seconds. Const seconds equals time.get seconds. We will also find what the meridian is. Is it AM or PM? We'll have to write the following. Const meridian equals, let's examine our hours. Is our hours greater than or equal to 12? Our time in hours is going to be in military time. I believe that's 0 through 23 technically. If hours is greater than or equal to 12, ternary operator. If this is true, meridian will be PM. Otherwise, meridian will be AM. With hours, we're going to reassign it. Let's say that it is 1 p.m. So hours will be 13, 1 hour after 12. If I don't want to display my time in military time, I'm going to reassign hours. We'll take hours modulus 12. Modulus gives you the remainder of any division. For example, if hours is 13, 13 modulus 12 has a remainder of 1. So that's how you can convert from military time. Use modulus 12. What if hours is 12? 12 modulus 12 is 0. If it's 12 o'clock, we don't want to display 0. We can add the following. Use the OR logical operator. Or return 12. If this equation is 0, that is equivalent to false. So using the OR logical operator, hours would instead equal 12. Then, within format time, we're going to return one long template string. We will display a placeholder with hours, colon, a placeholder with minutes, colon, a placeholder with seconds, space, placeholder, our meridian. Then within our span element, we will display, embed some JavaScript, call the format time function. Here's the current time for me. It is 7:52 at night, PM, and the time is updating. Now we have a problem. If one of our units of time is a single digit, we don't have any leading zeros. So let's fix that. We will declare a function pad 0. There's one parameter. We have to pass in a number. With hours, minutes, and seconds, we will pass each of these units of time to the pad 0 function. So we will enclose each of these within the pad 0 function, then return a result. So let's pad our hours with 0, pad our minutes with 0, and pad seconds with 0. Okay, we have undefined, undefined, undefined. That's okay. So within pad 0, we have to return something. We need to check to see if our number is a single digit. We can do that with checking to see if number is less than 10. If it is, it's a single digit. We'll use the ternary operator. Is our number a single digit? Is it less than 10? If that's true, we're going to return a string of 0. If not, we don't have to do anything. We'll return an empty string. We will take all of this, enclose it within a set of parentheses, return either 0 or an empty string, plus the original number. For example, if our number was 1, 1 is less than 10, that is true. We'll return a string of 0, then use string concatenation, and add our original number of 1. So we would return 0, 1. If our number was 12, well, this condition is false. We would return an empty string plus the original number of 12, which would give me a string of 12. So here's the result. We have each unit of time with the leading 0, if it needs it. And we have successfully created a digital clock component. And the cool thing about doing this in React is that we can reuse this component whenever we want. We can create one digital clock component, or another, or another, or another, and let me refresh these to synchronize them. These are all individual components running their own code. Alright everybody, so that is how to create a digital clock component using React. Hey everybody, today I gotta explain use context in React. Use context is a React hook. It allows you to share values between multiple levels of components without passing props through each level. What we'll do in this example is create 4 components, components A through D. Each component will be nested within one another. So within our source folder, let's create a new file for component A. This will be a JSX file. We will create a function-based component named component A. No parameters for now, and be sure to export it. Export default component A. Within this component, we will return some HTML. We will return a div element. The div element will have a class name of box. Within this div element, we will create an h1 element that has text of component A. Within our app component, we will import component A. Import component A from its location ./component A.jsx. We will return a single component A component. We're also going to add a little bit of CSS to visualize it. We will select our class of box, add a border of 3 pixels solid, and padding of 25 pixels. Here's component A. We're going to copy this file of component A and paste it 3 times. We will rename the second copy as component B, the third as component C, the fourth as component D. We have component A, B, C, and D. Within component B, rename any instance of component A with component B. The same goes for C and D. From component A, we're going to import component B. Import component B from its location, component B.jsx. After our h1 element, we will include one component B component. We have component B within component A. Now within component B, we will import component C. Import component C from its location, component C.jsx. After our h1 element, we will include one component C component. So we have component C within component B within component A. Within component C, we will import component D. Import component D from its location, component D.jsx. After our h1 element, we will include one component D component. We have component D within component C within component B within component A. I've organized my tabs. A, B, C, D. Within component A, we're going to create a state variable, const user, and a setter for user equals the useState hook. We will need to import it. Type in your username. I'll type in bro code for mine. At the top, we need to import from React, use object destructuring to get the useState hook from its location of React. Now, after our h1 element, I will create an h2 heading. We will embed some JavaScript. We'll display a template string of hello, add a placeholder, your username. So within component A, you should have an h2 heading that displays hello and your username. Within component D, What if I would also like to display my username? Well, from component A, I would have to pass props down all the way to component D. I'll have to pass them to B, which will pass them to C, which will pass them to D. So if we were using props, this is what we would have to do. Within component B, we will pass in props, set user to equal our user. Within component B, we'll have to set up props. Props will be the parameter. Within component C, we will set user to equal, embed some JavaScript, props.user. Within component C, we'll set up props again. Within component D, we will set user to equal, embed some JavaScript, props.user. Then within component D, set up props again. After our h1 element, let's create an h2 element. We'll embed some JavaScript, use a template string, display by, add a placeholder, access props, our parameter, access the user. Within component A, we have hello, your username. Within component D, we have by, your username. By passing props down each of these nested components, this is known as prop drilling. We're drilling down to the center component. Passing props down this long chain can become very tedious, but there's a better solution, and that is with the useContext hook. The useContext hook allows us to share values between multiple levels of components without passing props down through each level. However, we have to set up a provider component. Which component has the data we would like access to? In this case, it would be component A. In component A, we have that state variable of our username, which we named user. So within our provider component, we have 3 steps. We have to import create context from React. So within component A, we already have useState, but we also need create context. We need to create some context and export it. Export const. Then we need a unique name for this context. We're working with the username. Let's name our context user context. The context name should be descriptive of what you're working with. If the data we're working with is a color, we could say color context equals create context, and this is a function. Now the last thing we need to do is wrap any children components within this special provider component. We are going to wrap component B within another component. We will take our user context, access provider, set the value equal to be some JavaScript, our value of user. And we just need to wrap this component of component B. Component A is now the provider component. It's going to provide a value of user. We no longer need props. We can get rid of these for each component. After I deleted props from component B, well, our username is now undefined within component D. We broke that chain. All right. Any component that needs this data, we will set up to be a consumer component. You can have more than one. We'll have to import the useContext hook from React, as well as the context that we set up. We're exporting it, so we need to import it elsewhere. Within component D, we will import from React, use object destructuring, the useContext hook from its location of React. We also need the user context. Import, use object destructuring to get user context from its location of component A. That was the original location where we exported it from. We'll use the context, get the context, and store the value. We'll do that inside of our component. Const user equals use context hook. We're going to pass in our user context as an argument. And now we have access to user. We'll use a placeholder and add our user. And that has appeared to work. We have displayed by your username. We have avoided prop drilling. Instead of drilling down to the center component to pass down a value, by using useContext, we traverse up the component tree to find the nearest provider, which would be component A. Component A is the provider component. Component D is a consumer component. And you can have more than one. So let's do the same thing with component C. We need these 2 lines of code. Really, we can just copy them, because I'm lazy. And we need to create a constant of user, or some other descriptive name for this value. Use context, pass in our context of user context. Let's add another h2 element. We'll embed some JavaScript, use a template string. Let's say hello again, add a placeholder, our username. So within component C, we have used useContext again. Without prop drilling, we're displaying hello again, your username. Any component that's a child component of our provider component of A has access to this value that we set up. All right, everybody, so that is the useContext React hook. It allows you to share values between multiple levels of components without passing props through each level. If you have a lot of nested components, passing props down to each level can become very tedious. This is a way to avoid that. And well, everybody, that is the useContext hook in React. Okay, let's do this, everybody. We gotta talk about the useRef hook in React. UseRef, meaning use reference, is very similar to useState. UseState stores some sort of value, or an object, or an array. Whenever the state value changes, useState re-renders the component, which isn't always what we want. UseRef, meaning use reference, it doesn't cause re-renders when its value changes. Use useRef when you want a component to remember some information, but you don't want that information to trigger new renders. UseRef is helpful with accessing and interacting with DOM elements, handling focus, animations, and transitions, as well as managing timers and intervals. useState triggers re-renders. UseRef doesn't. In order for us to use the useRef hook, we have to import it from React. Import useRef. For this sample program, we'll be using useState originally. Then we'll switch it up and use useRef to see the differences. We'll begin by using the useState hook. We will have a state variable of number and a setter for number equals useState. I will set the initial state of number to be 0. We will return a button element. The button will have text of click me. I will set the onClick event handler equal to a function of handle click. Then we just need to declare this function. Function handle click, no parameters. What do we want to do? When we click on the button, let's use the setter for number and increment the previous state of number by 1. N plus 1. Whenever my number updates, it's going to cause my component to re-render. I can demonstrate that with the useEffect hook. So before our function of handle click, let's use useEffect. With useEffect, if we don't pass in a dependency array, we'll perform some code every time this component renders. So for this demonstration, let's console.log component rendered. Anytime this component renders, useEffect is going to execute this code, where we display component rendered. So I'm going to go to my console. When your component mounts, you'll render your component twice. That's if you're in strict mode. Just temporarily for this demonstration, I am going to remove strict mode. So our component renders once on mount. Whenever we update the state of a state variable, that causes the component to re-render. That's where useRef comes in. useRef doesn't cause a component to re-render when its value changes. It's kind of like an escape hatch. So instead of using a state variable, we're going to use ref. useRef means use reference. We're referring to something. We will declare a const of ref equals useRef function. useRef returns an object that has one property of current. If you pass in a value to useRef, you can set the property of current to some value. I will set the current property of my ref object to be 0. Then within handle click, I will access my ref object, access the current property, then I'll have access to that value. I will set the current property of ref to be ref.currentProperty plus 1, or we could use the increment operator. Every time we click the button, we will increase the current property of ref by 1. And then I will display what that value is. Console.log, access our ref object, access the current property. Let's go to inspect, console. Our component rendered once. Every time I click the button, our component isn't re-rendering. We've only rendered it once. The value stored within the current property of my ref object is increasing each time I click the button, without the component re-rendering. useRef returns an object that has one property, a property of current. Let me show you what would happen if I were to console.log ref, my reference. So here's ref. It's an object. It's an object with one property. When we create this reference, the initial value is going to be the initial value we pass in to useRef, 0. But if I were to change this, let's say that the initial value is pizza. Ref is an object with one property of current. The value stored within my current property is a string of pizza. So what we'll do in this next demonstration is create an input element. But we do need to wrap all this HTML within a single element, because we can only return a single element at a time normally. So we will enclose all of our HTML within a div. So we have a button and an input element. The current property of your ref object can also refer to an HTML element, and that's where useRef is really helpful. Your reference should be descriptive of what you're referencing. We will reference this input element. I will name this reference as input ref. I will set the initial value to be null, meaning no value. Within that HTML element, we have to set the ref attribute equal to that reference of input ref. The ref attribute of an HTML element, it's a special attribute used to create references to elements. After our component renders, I'm going to console.log input ref. We'll take a look at what it contains. So here's our input ref object. It's an object. The property of current is set equal to this input element, and this input element is one gigantic HTML object. If we make any changes to this HTML element, it's not going to cause this component to re-render. And to even check that, I have console.log component rendered within useEffect. If this component re-renders, we'll console.log this message. So what would we like to do? When we click the button, let's take our object of input ref, access the current property. That will give me my HTML element, my input element. I will use the built-in focus method to give this element focus. If I were to click on this button, our input element is going to have focus, and it doesn't cause the component to re-render. Just to check that, let's go to inspect, console. Our component rendered once, when we initially mounted it. Every time I click the button, the component isn't re-rendering, which is good. We don't necessarily need the component to re-render every single time. Not only that, let's change the background color of our text box. We can really do anything we want with this HTML element without causing the component to re-render. Let's access our input ref object, access the current property. That will give me this HTML element. Let's access the style property, access the background color, and set it to be yellow. Now when I click the button, we have focus, and the background color changes of this input element. Let's create a few more HTML elements. Let's copy this button and this input element, paste it twice. We'll have click me 1, click me 2, click me 3. We'll have to create a few more references. Let's copy our current reference, paste it twice. Input ref 1, input ref 2, input ref 3. The ref attribute of each input element will be input ref 1, then input ref 2, input ref 3. We'll create 2 more handle click functions, just to keep it simple. Handle click 1, handle click 2, handle click 3. Handle click 1, handle click 2, handle click 3. So we need input ref 1, input ref 2, input ref 3. When we click on one of these buttons, the background color is going to change, as well as the input element having focus. When we click on one of these buttons, I need the background color of the other input elements to reset back to normal. So really we can just copy what we have for the background color, but access input ref 2 and 3. Set the background color to be an empty string for the default. If I were to click on button 1, input ref 1 is now yellow. When I click on button 2, the background color is yellow. Input element 1 and 3 now use the default color. And the same thing goes with input element 3. If I were again to go to inspect, console, well, our component still only rendered once. By interacting with these buttons, it doesn't cause the component to re-render. That's because we're using useRef and not useState. You don't need to write all this, but I changed my program around so it's using useState rather than useRef. Every time I click one of these buttons now, since we're using useState, the component re-renders. By avoiding re-rendering when it's not needed, it's going to make your component more efficient. Alright everybody, so that is useRef. useState re-renders the component when the state value changes. useRef means use reference. We're storing a reference to something. When you use useRef, it returns an object with one property of current. That current property can store a value, an array, an object, or an HTML element. When the stored value changes, it doesn't cause the component to re-render. This is helpful with accessing and interacting with DOM elements, handling focus, animations, and transitions, as well as managing timers and intervals. We'll be working with useRef in the next video, where we will be making a stopwatch component. And well everybody, that is the useRef hook in React. What's up everybody? In today's video, we're going to create a working stopwatch using React. So sit back, relax, and enjoy the show. Okay, let's get started. Within our source folder, we're going to create a stopwatch component. Stopwatch, and this is going to be a JSX file. We will be working with function-based components. Function, stopwatch, no parameters, then be sure to export it. Export, default, stopwatch. In this program, we'll need 3 different hooks. Let's import them. Import from React, use object destructuring. We'll need the useState hook, useEffect, as well as useRef from its location of React. We do need to return something. For the time being, we're going to return a fragment. Okay, let's import our stopwatch. From our app component, we will import stopwatch from its location of stopwatch.jsx. We will return a single stopwatch component. And that is all we need for the app component. Within our stopwatch component, we'll make a few declarations. We'll be using the useState hook as well as the useRef hook. We'll need to check to see if our stopwatch is currently running. We will use useState. Const is running, and a setter for is running. Equals useState. I will set the initial state of is running to be a boolean of false. our stopwatch is not currently running. We'll also need to keep track of how much time has elapsed. That will also be a state variable. Const elapsed time, and a setter for elapsed time. Again, we're going to use useState. I will set the initial state of our elapsed time to be 0 for 0 milliseconds. We'll be working with intervals. If we start an interval, we need to clear it if we're not using it. We will use ref to create a constant of interval ID ref equals use ref. We will set the initial value of current to be null. When we start our stopwatch, we'll have to get the current time. We'll store that as a reference using useRef. Const start time ref equals useRef. I will set the initial value to be 0. Our start time will be 0 milliseconds. A few things we'll need. We'll need to use the useEffectHook. We will pass in a function and a dependency array. The dependency array is going to have one state variable of isRunning. Basically speaking, when we mount our component, and if isRunning ever changes, we'll perform some side code, whatever's within useEffect. This is where we'll start our interval to move time forward. We'll get back to that later. We will create a function to start our stopwatch. A function to stop. A function to reset. And a function to format time. Format time. Within our return statement, let's return all the HTML we'll need for this program. I will create a div element to act as a container. This div element will have a class name of stopwatch. Within this div element, we will create a nested div element that has a class name of display to display the time. When we display the time, we will embed some JavaScript and call the format time function. Within our format time function, just so we can display something, I'm going to return a template string that displays a bunch of zeros. Really, I'm just using this as a placeholder. So we are returning a string of a bunch of zeros. We'll have 3 buttons. These 3 buttons will be within another div element. This div element will have a class name of controls. We will create a button that has text of start to start the stopwatch. This button will have a class name of start-button. With this button, we will set the onClick event handler to be a JavaScript function. We will pass in a callback to the start function to start the stopwatch. Then we need a button for stop. Let's copy this button, paste it, change any instance of start to stop. OnClick will be a callback to stop. The class name will be stop-button. The text will be stop. Then we need a reset button. Let's copy our button, paste it, change any instance of stop to reset. We will pass in a callback to the reset function. The class name will be reset-button, and the text will be reset. And that is all the HTML that we need. Go to our CSS style sheet. Now we'll apply some CSS. Within the body of our document, we'll use Flexbox to display each component. Display flex. I will set the flex direction to be a column. There's not really going to be any apparent changes until we add more components. Then I will align items in the center and set the background color to be a light gray. But I'll use HSL values. I will set the lightness to be 95%. Okay, let's zoom out. Then I will select the class of stopwatch. This class contains our stopwatch, everything within it. I will again use Flexbox, and really I'll just copy these 3 properties from the body. So display flex, flex direction column, align item center. I will add a border of 5 pixel solid. Border radius to smooth the corners of 50 pixels. Set the background color to be white. Then add some padding of 30 pixels. Alright, let's work on our display next. The text is pretty small. We will select the class of display. Increase the font size to 5 rem. Set the font family to be monospace, or some other font that you like. Let me zoom back out. I will set the font weight to be bold. I'll change the color. Pick a color for the font color. I will set the lightness to be 30%. I'll add a text shadow effect. Text shadow, 2 pixels by 2 pixels for the vertical and horizontal offset, and a blur radius of 2 pixels. And pick a color. I'm just going to lower the alpha to 75%. Just so it's more transparent. Then add a little bit of margin to the bottom. Margin, bottom, 25 pixels. Okay, and that is what we need for our display. Let's work on our buttons next. So within our div element of controls, I would like to select all button elements within this class. Select our class of controls. Select any buttons within our controls class. Let's set the font size to be 1.5 rem. Set the font weight to be bold. Add some padding of 10 pixels by 20 pixels. Surround each button with some margin, 5 pixels. I will set a minimum width of each button to be 125 pixels. Remove the border with border none. Use border radius to round the corners, 10 pixels. When we hover our cursor over a button, let's change our cursor to be a pointer. And that does work. I will set the color, the font color, to be white. We'll change the background color pretty soon. We'll also add a transition effect. Let's select the background color and use an ease transition after 0.5 seconds. We will ease. Let's select our class of start button. Class start dash button. Pick a background color. I'll pick something green, meaning go, because we're starting our stopwatch. Background color green, but I'll use HSL values, because I think they look better. I've already pre-picked a color. I will select these values. For the hue, 115. For the saturation, 100%. For the lightness, 40%. Let's also access the hover pseudo class. Let's copy and paste our start button, access the hover pseudo class. When we hover our cursor over the button, what do we want to do? Let's take the lightness and subtract 5%. 5% from whatever it currently is. I'll set mine to be 35%. So the color should get a little bit darker when you hover your cursor over the button. Let's do this with our stop button. We'll copy and paste what we have for our start button, change start to stop. I'll make the background color red, but I'll select something specific. For the stop button, I'll set the hue to be 10, the saturation to be 90%, and for the lightness, 50%. Let's copy and paste this background color within the hover pseudo class. Set the lightness to be 5% darker. And that does work. Now for the reset button, let's make it blue. Change stop to reset. And pick a blue color. For the hue, I'll select 205, 90% for the saturation, for the lightness, 60%. When we hover our cursor over the reset button, I will set the lightness to be 5% darker, so 55%. And that looks pretty good. And we can close out of our CSS style sheet. let's go back to our stopwatch component. Let's work on the start, stop, and reset functions. When we press the start button, we will call this function of start. So to start the stopwatch, we're going to use the setter for isRunning and set that to be true. We will set the state of isRunning to be true. Once we press the start button, we want this program to be running. We also need to set the start time reference. Updating a reference doesn't cause our component to re-render. If a state changes, it does cause the component to re-render. We're going to set the start time reference. This is an object. We will access the current property and set it equal to, now we need to calculate what the start time is. So if we were to get the date right now, this is going to return the current date and time in milliseconds, minus the elapsed time, which is initially 0. So just to show you what this looks like, I'm going to console.log the current property of my start time reference object. If I was to start our stopwatch, we'll be given the current date and time in milliseconds since epoch. Think of epoch as when your computer thinks time began. It's usually a date around the year 1970. 1.7 trillion milliseconds has passed since epoch. If I were to start the stopwatch again, you can see that this number increased slightly. We're converting the current date and time into milliseconds. By keeping a reference to when we started the stopwatch, we can see how many milliseconds has elapsed since then. That's kind of the general idea. We can get rid of console.log, we don't necessarily need it. Keep it if you would like. To stop the stopwatch, we're going to set our boolean of isRunning to be false. That's all we need to do. Now for reset, we're going to set the elapsed time to be 0, because we would like to reset everything. Set the state of elapsed time to be 0. And we will also set isRunning to be false. Set isRunning false. If you would like to stop the stopwatch when you reset, set isRunning to be false then. Since we have a dependency array, when we mount this component, and any time the state of isRunning changes, we'll perform some side code. I think what we'll do first is check to see if isRunning is true. If isRunning. If our stopwatch is now running, we'll need to create an interval to move time forward. We will use the set interval function. This has 2 arguments, a callback to a function, and a time in milliseconds to repeat this interval. Let's say after every 10 milliseconds, we'll perform some code. I'll use an arrow function. After every 10 milliseconds, we will set our elapsed time to be a new state. We will get the date right now minus whatever our start time was. We can use our reference. Start time ref, access the current property. Remember that was in milliseconds. So get the time right now, subtract what our start time was, and that will give us our elapsed time, because we're using the setter for elapsed time. In order to clear this interval, we'll need to keep track of it by its unique ID. The set interval function returns that ID. We will take our reference of interval ID ref. It is an object. We will access its current property and set it equal to that reference. We should add a cleanup function to the end of our useEffect hook. We will return a function, a cleanup function. When isRunning changes, or we unmount our component, what would we like to do? We need to stop the interval from continuing. If we don't, it may lead to unexpected behavior. We will use the clear interval function and pass in that unique ID. Access the current property of our interval ID reference and clear it. That will allow us to clear this interval, so our program stops running. Now we just need to fill in the format time function. We have elapsed time. It's going to be in milliseconds. We need to convert it to hours, minutes, seconds, and milliseconds. We'll start with hours. Let hours equals take our elapsed time. Now to convert milliseconds to hours, you can follow this formula. Take our elapsed time, which is in milliseconds, divided by, there's 1,000 milliseconds in a second, times 60 seconds in a minute, times 60 minutes in an hour. enclose this equation with the floor method of math. Math.floor. Okay, let's calculate minutes. Let's change hours to minutes. What we got to do is take 1,000 times 60 modulus 60. Modulus gives you the remainder of any division. Once our minutes unit hits 60, we need to reset it back to 0. That's why we're adding modulus 60. We don't want it to continue to 60 or something above 60. Then we have seconds. Let seconds equals elapsed time divided by 1,000 modulus 60. And milliseconds. Let milliseconds equals our elapsed time modulus 1,000. If you don't want to display all 4 digits of milliseconds, we can divide this by 10 to display only the first 2 digits. We will return a template string. We will display the hours, placeholder, minutes, placeholder, seconds, placeholder, milliseconds. Now, if you don't want to display hours, you can remove that. I'll only display minutes, seconds, and milliseconds. So here's what's going on currently. Let me stop it. So we can start, we can stop, and we can reset. However, I would like to format the time. I would like to display a leading 0. Well, we can use the pad start method of strings. So let's take hours equals, we'll use typecasting to convert hours to a string. Then follow this with pad start method. Pad this number with 2 0 characters. Let's do this with minutes. Minutes equals convert minutes to a string, and then pad it with 2 zeros. Seconds. And milliseconds. All right, let's see if this works. We can start, we can stop, we can start again, we can stop again, we can reset, we can start, and we can stop. Now, the cool thing about doing this in React, our stopwatch is a reusable component. If I were to go back to my app component, I can include as many stopwatches as I would like. Let's include 1, 2, or even 3. These are all individual components that have their own code to run. They all run independently, and I can stop them whenever I would like. Alright everybody, that is how to create a stopwatch component using React.